What is up, guys, and welcome to a new section. And in this section we're going to create a really cool, let's say, top-down dungeon game with a lot of enemies, boss fights, special enemies, and a lot of weapons as well. So let me just preview the game that we are going to create. So if I hit the play button over here, we're going to see a really cool main menu where we can click anywhere to start the game. So I can click here and we are going to see an animation coming towards the characters that we can select inside of this game. Currently, we can only select the one in the middle because in the section, you are going to have assignments to create these two characters same way as we create this one. So as soon as I click on him, he will be playable. I can move him and he will be able to rotate and all of that stuff. And when I pass now here, we're going to hear the sound of the gate opening and we will see this gate over here being opened, and then we will be able to pass through it. There you go. And now when we pass, we are in the level. We have different, bullets that we can use to shoot, different weapons, as you can see. And we also, you can hear the sound effects that we have for all of these weapons. So if I try to go here, well, first let me go into the scene and show you all of these enemies that we have. So we have these 4 enemies that are stationary currently, but they will follow us as soon as we pass a certain collider over here. Also over here, we have this flying enemy who is shooting at us. Well, I said flying, but he's a shooting enemy. Over here, we have the boss, and then we need to fight all of these in order to pass these gates. So if I go over here, I have set my weapons, actually my bullets, to be able to kill the enemies right away, so don't worry about that. You can also see how the shooting enemy is shooting me. So we have different bullets. So let me just kill all of these enemies, and there you go, there you go. So when I killed the last one, the gate over here is going to open. Voila, gate has opened. So now I can go over here and destroy all of these other enemies. So the other gate will be opened, and then I will proceed to destroy these others. And now we are here to fight the boss. As you can see, when the boss senses where we are, he is going to start shooting and run faster towards us, and of course we can kill the boss, and there you go. Now don't worry, this is where the level ends, by the way. Now don't worry for all of these bullets that you saw that just killed the players or these enemies from one shot. This is something that we set up in the game. It's very easy to do just by changing a few numbers. So I will show you how to do all of that. The point is that we are going to learn a lot of cool things inside of this game because a lot of complex stuff is happening behind the scene. As you can see, a lot of things are going on in this game. A lot of things that we will learn, such as different enemy AI, how to create an AI for small enemies, larger enemies, and even boss enemies, how to create different weapons, and how to utilize really, how can I say, simple logic. So simple logic in order to build a system that will allow us to reuse all of these components over and over again. Like literally, we're just gonna copy and paste, duplicate game objects, and then we have a totally new wave of enemies, a totally new and different experience inside of different parts of the level or even different parts of the game. So I don't want to stall anymore. I know you are eager to create this game, so as I am eager to teach you. I mean, this is from the past. I'm from the past because I already recorded, but I had a lot of fun recording this game because a lot of things you will learn inside of this section. So anyways, I'm going to throw that away and let's get into this section and create this really cool game. What it is, Game Dev Gangsters, long time no see. I mean, that's for me because I didn't record in about a month, but you're watching this probably, 5 minutes from the previous one. So anyways, what we are going to do here is first import the assets as we do every single time for a new project. And then I have already created a new project. This is a 2D project. We already know we passed the point of showing how to create a new project, okay? So over here, as you can see, we have the default, things like sample scenes. I'm simply going to rename this one to level 1 because this is going to be our level 1, and I'm going to do it like this and simply reload. So now going back to the asset part, I am going to import the assets, and here they are. Now you can download the assets. Link for them will be in the description or below this video. You will see a link to download the assets, and you will see a link to download this complete project, which I advise you to do because sometimes you just want to copy paste some code, such as the tag manager that we will do later on. Sometimes you want to compare your code with mine, so go and do that. Now we are going to select all of these except for the levels. So the level folder, don't select it because this is a Unity package. We are going to import this. We will see how. So select the fonts, sounds, and sprites and simply drag and drop them, well, not here into the scenes folder, but drag and drop them over here into the project and simply wait, for Unity to do its magic. And over time, Unity got pretty good, or pretty good at copying Unreal Engine when it comes to importing or slowly importing the assets. So thumbs up, Unity, you are importing assets as slow as Unreal Engine. So, I cannot compare you there. In that section, both engines are the same. So if you're looking for a way to import the assets slowly, you can pick either one or the second one. Anyways, so over here, we just ignore this. So don't worry about that. Probably I forgot to remove some data or .meta file because I took the assets from, the sample project or the one that I have prepared for this. Not important, just clear the console. So now we are going to import all of those packages. And how we're going to import the packages and what packages I'm talking about, well, they are these packages. So we are going to import them by going here, right-clicking, import package, and then custom package. And then from there, we are going to go, so let me just find them here. There you go, assets, and I actually need to go over here, volume 2, and then assets, and Poco the Adventurer, and over here into the levels. So we're going to import them, Dungeon 1, so click here, import, and you will see all of these things that need to be imported. So I'm simply going to click here, import, and of course, wait for Unity to do its thing. And there we go, it's imported. So over here, we will see that we have a prefabs folder. Don't worry about that. It has been imported with the import that we just did. Let me just import all other packages. So going here, we have the 2. And after I import them, we are going to see the contents of those packages. So let's go over here, import another custom package over here, 3, then we have 4, and we have the last one. So some assets are new. As you can see over here, we're importing the assets. You will see that these things are new or not being, imported before. And some of them are already imported, such as this decor _100.asset, these floor.1 tile assets, whatever the name is, and so on and so forth. Just click import, and there you go. Now let me just see here. So we need to import 3, so custom package over here, and now we're going to import 4, that is import, and last but not least, import package. This one is for the main menu, and there you go. So click import. So what do we have over here? Well, now if we go into the prefabs folder, and here into the levels, I have the dungeon level 1, 2, 3, and 4, and I can drag and drop them over here simply, and there you go. So this is my dungeon level, this right here. Now, of course, what we see now is, too big, and the reason for that is because we need to take the camera, so taking the main camera, and we need to set the size of the camera to 1, and this size is called the orthographic size. For what do we use it? Well, one of the things is this right here, as you can see. So we can resize the camera. And let me just select the camera again, so we can resize the camera. Another thing that we can use is to zoom in and out, and look at that. So when the value is negative, look at how the camera is zooming in. You see the assets are upside down. And this is one of the ways, as I said, that you can zoom in. So if you're creating a game where you have a sniper rifle, you can use this to zoom on your enemies and so on and so forth. But also if you're creating a pixel-based tile game where the assets are very small, you can also use this size to resize it. Of course, there are other ways how you can make the assets bigger, such as meddling or changing the value of the pixel per unit. We will see that, don't worry about that, but this is also one of the ways. I'm also going to reposition, or actually I'm going to create a camera holder here. So I'm going to create an empty game object and call it camera holder, and I'm going to set the camera as a child of the camera holder. And let me just reposition the camera to 0, 0, 0. But now I need to take the camera holder and position him at -3.87 on the X. On the Y, it's going to be -2.3, and on the Z, it's going to be -10. So this is how we are going to position the main camera. Don't worry about this. Why we have the holder, we will see later on, because we are are going to use the camera to create a shake effect, and for that we need a holder. Don't worry, we will see that. Now, how or what are these assets? How is this created? Well, this is created using Unity's tile system, same as over here. So this is our dungeon 1 level, and I can turn it off and I can drag and drop the level 2. Look at this. So now we have the level 2. I can also remove level 2 and show you the level 3. So this is the level 3, and last but not least, this is our level 4. There you go. So I have pre-made all of this. Now don't worry, I'm also going to show you how you can do that. But essentially, I just wanted to introduce you to what did we just import. So, you see the whole level and all of this right here. And you're asking, what is it, teacher? Well, I need to tell you. So before we wrap this video up and I go and show you how to do these, of course, we covered this in volume 1, but I cannot assume that you attended volume 1 because I said that the requirements for volume 2 is that you know the basic things that I listed. So I cannot assume that you went through volume 1, but you understand all of the things that we're talking about. So over here in the camera, main camera, for the background color, I'm going to click here and hexadecimal, change the color to 13221B. So this is the hexadecimal, so 13221B. And there you go. So we wrap things up, and this is for the importing, and this is going to be our first level, and basically the level that we're going to use to experiment, to create the enemies, to create the player and all that stuff. But in the next video, I'm going to show you how you can actually create your own tiles, and we're going to tackle the Unity tile system and see how that works so that we will know, or you're packed with knowledge to create these sorts of levels on your own. So yeah, I will see you guys in the next video. What up, game dev gangsteronia? In the previous video, we have imported these levels, or one of the levels, this one right here, and it's already pre-made, so I'm going to show you how we can actually create it for ourselves. Now, I did cover this in volume 1, so if you are from that course, you don't have to watch this video, you can just skip it, but if you're not, and I cannot assume that you were in the course, so that's why I'm creating this video, just to show you and demonstrate the basics, so you can watch this video. So the first thing that we are going to do in order for this, or to create it, we need to right click over here and we need to go under 2D object, and from there into the tile map, and we're going to create a rectangular. And there you go. So this is our tile map that you can think of as a canvas where we're going to paint. You can see all of these grids over here, which are basically where, or every single grid over here is going to represent one tile part in the whole level. So this one right here, you can rename it. I don't know, you can say, for example, ground. And over here into the assets, I'm just going to create a new folder that I'm going to say test, and for whatever reason it did not create, so go over here, test, delete after testing. And in order for us to create these tiles, because this is only the canvas, we need a palette or something that we can use to draw on this canvas. And in order for us to do that, we need to go under window and then 2D and then click on this tile palette. Now this is what is going to come out of it, and mostly for, or 100% for you, it's going to be like this. It's going to be floating. So don't get confused if it's floating or if it's not floating. So this is the tab that you need, and if it's floating, you can simply dock it wherever you want to dock it. I can dock it here where the hierarchy is, or over here where the inspector is. That is totally up to you. So now that we have the palette tab, we need to create a new palette, which is going to be, the palette is the thing that you put colors on when you want to draw. So over here, I'm going to click here, create new palette, and give it a name. So let's say, for example, ground palette. And of course, we are going to click here, create, and choose where we want to save it. And it's going to be here in the test, and choose, and there you go. And from here, you can select from multiple palettes that you have created. If you want to create a new one, you're going to click here, create a new palette, and do the same exact process that I just showed you. Now, what is the trick here with the palette? How can we use the palette to draw? Well, over here, you see this, it says drag tile sprite or sprite texture assets, which are going to represent the tile parts that we are going to use. Basically, they're going to represent the color in the palette that we are going to use to draw. For that, we need to go here into the sprites, and then we can go here into the level. And of course, these parts, they can be texture or a sprite, individual sprite, or they can be a sprite atlas or basically a sprite sheet. So they can be, you know, multiple images in one. So you can simply drag that over here, and you can see when I drag it, it automatically create this grid over here that we can use to basically, you know, position them or have them inside of the palette. So I'm going to go here into the individual ones, and I can, you know, for example, drag and drop this floor, and automatically it's going to tell me or ask me to generate or create a new tile. You're going to name the tile based on, you know, what that tile represents for your level. So you want to make meaningful names so that, well, you know for what that is used. And I can go over here. I want to save it into the not sprites, but over here, assets, and then over here. So this, because I'm going to delete this anyways, so there you go. Now when I created this, I can go here, and here it is. This is the ground, you know, this is that floor. Look at that. So we have this one over here. There you go. Now I can use this. So I can click on this drawing tool, and here is the one that I want. So I can click on this brush, and when I click on the brush, I can then click on the individual tile, and then here I can start to, you know, put that tile. There you go, 1 tile, 2 tile. Now you can see this right here that they are too small. Now the reason for that is because these tiles, you know, depending on the size that you are using them, they can be small. You can, you know, create them to be the exact same size that you need them to. Another way is to go and click on the ground and resize this cell size. So I can go here on the ground palette, and can I see where the size is? I believe the size is 1.16, or actually 0.16. So I can click here. Let me just click on the ground, and from here I can say 0.16, and for the Y, 0.16. Is it? Let me just go here into the scene. Yes, it is. And there you go. So they are, and this is now how the tile looks like, or the ground, the palette, basically. So if I go here, I can, you know, do this, and there you go. So now they are right next to each other. So they are 0.16, and you will, how do I know this? Well, depending on how you construct your assets. So these tiles are 16 by 16, I believe. If you have 32 by 32, they're going to be 0.32 over here. And you are going to see with your pixel artist or whatever. I don't know how that creation goes, okay? I don't know. I'm not an artist. Or when you find an asset online, you're going to see that the, you know, the width and the height of that tile is this by this and all of that stuff. So there you go. Now, of course, as I said here on the palette, I can go and let me go back into the sprites and individual ones, so level and over here, and I can take this one, for example, and I can put this over here. This is going to be floor 4, and I am going to put this over here, save, and now I can click on that one, and I can go here and I can, you know, draw on this canvas over here. Now, there is no magic way, do this, your level is going to look like that, or do that, or whatever. This comes back to your creativity, because we're game developers. At the end of the day, I cannot, or the computer cannot create a game that you imagined. You need to put your imagination in the computer, not vice versa. So the computer cannot read your mind and, you know, create the game that you have in your mind. Instead, you need to simply put the parts of the level that you want over here, and then use them and position them one by one until you have something like this, for example. So over here, and I'm going to remove this one, until you have, as I said, something like this. So this is how this part is created. So you have a grid cell here, then here, then here, then here, then here, and all of that stuff. So here, 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 and all of these are parts of those levels that you can, and of course later on when you have your own level, you can use all of those, you know, parts to create something like this, or create something as we saw in the preview for, you know, our other level parts. So we have here our level 2. So create something like this. I'm going to remove this here, create something like this, and so on and so forth. So this is basically how it works, and I encourage you to try to do these, or try this out on your own, in order to create all of these level parts. I'm going to delete this ground because we don't need it. This was just for testing purposes. And let me go back over here and delete this testing so you see how this actually works. And I am going to use this one. And you can also understand why I have prepared these levels, because it will be a lot tedious for you. It will take a lot of time, because that's game development. You need to be aware of that. It takes some time, a lot of time, you know, to create a certain effect or to create a certain level or whatnot. So it takes time. It's simple as that to create something like this. And you will be watching me, okay, I'm going to put this here and this tile part here and this tile part here. You know, it can get a bit tedious, and I would probably need, I don't know, to create all 4 levels and the main menu one, so 5 levels that I have. It will take me about, you know, probably 10-15 lectures to do all of that, and the length will be anywhere between 1 and 3 hours. You don't want that. So that is the reason why I have prepared it, and I'm showing you right now. I have showed you how you can, with the help of the tile palette, create all of that. And I'm simply going to close this because we don't need this tab, and you can experiment. Be free to experiment. You have enough assets over here. So let me go into the sprites. You have enough assets here in the level. You also have over here, so you have this tile map or whatever, or actually the sprite sheet or whatever. So you can try to use this as well. Maybe this one to just draw. That's all there is to it. And over here you can find more of these. So there you go, another atlas like that. So you can use this one over here. There you go, and all that stuff. So if something was not clear, make sure that you ask in the comment down below, and I will see you guys in the next video. Now that we have the tiling out of the way, let us create and animate our player character. Now over here in the sprites folder and inside the pixel shooter and towers, and here we have the characters folder. So here we have our 3 characters. And what I'm going to do with these characters is, first I'm going to drag this one over here, and there you go. He's not visible because we need to change the sprite sorting layer. And over here I have already prepared the ones that we need. So I'm going to go here and, you know, for you to see. So as you can see, we have these sprites or sorting layers. So just make sure that you create them. So we have the level, the bullet, the enemy, the player, and the UI. So these are the sorting layers that we have in this order. So in this order, and of course we're going to put the player on the sorting layer player. So if I go here and say player, there you go, we see the player, but he's not pixelated how I want him to be pixelated. And if I select all of these, there is a fix, so we can select them, and over here inside of the inspector we can change this filter mode from bilinear to point no filter. So if I click on that and then apply, you will notice and pay attention to the player how pixelated he is right now. Now don't even ask me how this or what this point no filter does behind the scenes. What it is, I don't know, but it just changes the appearance of the sprite, as you can see right here. I am also going to change the pixel per unit. So I'm going to select all of this here and change the pixel per unit to 115 and hit the apply button, and it is going to resize the player a little bit. So now we can start animating him. And over here you can see we have all of these animations. We have the down, down empty, down side, down, or side down, side up, and all of that. So we are going to go in these one by one. So our down, I'm going to change well, first things first, I'm going to select these and change them to sprite mode multiple and hit apply. Now I'm going to demonstrate this only for this player or player 2. You're going to do that for player 1 and player 3. That is going to be your assignment. You're going to create the same way. Now you don't have to do it right away, but after we finish creating the character, his animations, his movement, you're going to do the exact same thing for player 1 and player 3. And I'm going to do that for player 2. So here on the down, I'm going to go into the Sprite Editor, and here is my Sprite Editor. I'm going to slice all of that, and I'm going to not revert, but go again and slice and hit apply. So do the same thing for the side. We don't need the side empty. So over here, Sprite Editor, slice and hit apply. There you go. Go here for the side down. Again, into the Sprite Editor, slice and then apply. And we have 2 more. So side up. And I know sometimes, as I said, it can get tedious. I talked about that in the previous video, but this is game development. You are a game developer. This is your life. Enjoy it. Just kidding. Hit apply, and there you go. So now we can, or we need to actually create all of these animations. And in order for us to do that, I'm going to take the player side over here, and I'm going to place him here inside of our game. Where is the player? Here he is, but I need to move him over here where the beginning of the level is. So this is the beginning of the level. There you go. I am going to set his sorting layer to player so that we can see him right away. And also over here for our dungeon, dungeon. So we have let me just see here, the floor. Is this the floor? There you go. Set the floor to over here, level, layer. There you go. And what happened with the floor? There we go. Yeah, we see it. Designs. Let me see over here. Yeah, the designs. There you go. We're going to set that to the level and voila, there you go. So everything is fine now. So for the floor and the designs inside of the level. Now over here, I'm going to change the name of this one to player 2 for obvious reasons, because we said that I'm going to do this for player 2. You're going to do that for player other. So 1 and 3. And over here, I'm going to attach the animator component on the player. I'm also going to attach a box collider on the player. Now we are going to resize the box collider a little bit. So I'm going to go here and do something like this. Or basically, I need to move him a little bit down and something like that. Here for the X, it's going to be, well, just the sizes. So the size is going to be for the X 0.10, so you can say 0.108, and over here, there you go. So this can be 108, there you go, or maybe just a little bit here, something like that, and this goes a little bit here. There you go. So this is how I want the collider for my player to be. Now, I don't want to make it a trigger, so that's a big no-no. And over here, I'm going to attach a rigid body 2D, but I'm also going to set over here the gravity scale to 0, because if we don't set the gravity scale to 0, the player will start to fall down. And these are the basics of, 2D physics and whatnot. So we know that. Let's go here in the assets, and I'm going to right click and create a new folder, and I'm going to call this one. Why the folder is not creating from the first try, I don't know. So animations, and inside of this folder, I'm going to right click and create our player animations. Now we do need to create the controller. So right click and go here and create an animator controller. So create an animator controller. This one is going to be player controller. And select the player 2 and then drag and drop here the player controller. Now, of course, you can, call this bad boy player 2 controller, because we're going to have player 1 and player 3. That is, again, your assignment. And now I can simply create all of the animations that we need. So we are going to have, a few animations such as the down, the up, the side down, and side up. So we can, let's go over here and selecting the player, I can click here, create, and in player animations, this one is going to be player _1 down. So that is one of the animations that we are going to have. We're going to have the side. So again, going over here, not on that one. So over here, create new clip. And this one is going to be player _1 side, not sewed, it's side _down. So this is the name of the second animation. Let me just go here, new clip. We are also going to have here player _1 up, not eep, it's up. We are also going to have over here player _1 side. There you go. And we have the down, we have up, we have the side, we have the side down, and we need the side up. So going back over here, player _1 side up. So these are all the animations that we need for our player. And of course, now we are going to drag and drop for, different animations. So let's go over here into the sprites and inside of our pixel shooter and characters. So going back here from the down animation, here is our player down. So simply select these 4 sprites and put them here. I'm also going to change here the sample rate to 24. Going back to the side over here, let me just click the drop down list on the side, select all of these and drag and drop them over here. And again, I'm going to go here, sample rate is 24. Moving forward, we have the side down. Here it is. So select the side down and simply put that over here. Let's go here into the sample rate, 24. There you go, 24. There you go. Side up. So select it and over here, apply it. Voila. Let's go here, sample rate 24. And last but not least, player 1 up. Selecting the up over here and simply attaching it. And from here, sample rate 24, there you go. And voila, we are done with the animations. Now we are done with creating them. So now we are going to delete all of them. And you're going to be like, teacher, what did you do? Just calm down. Okay, what we are going to do now is we're going to right click and go here, create state. And we're not going to create an empty state. Instead, we're going to create from new blend tree. And there you go. I'm going to call this blend tree player movement. So something like player underscore movement. And a blend tree is something that we did not introduce by far or until now. So far, we saw that we have animations like the ones that you have, or that we saw a moment ago. So we have states. These states have animations. So this is one state, the second state, and they have animations. We can, move between them and all of that stuff, and, yada, yada, yada. But we also have blend trees that we can go over here and we can, attach animations on these blend trees. And then the blend trees will do, their thing. So the blend tree is the one responsible for all the animations and blending between them. Now, of course, for that over here, we do need to create a parameter. So we are not going to have this blend parameter. So I'm going to change the name, this one to face X. So this is going to be the one parameter. Going here, a new float, and this one is going to be our face Y parameter. Voila. And last but not least, we are also going to have a trigger, and this trigger is going to be the death. And don't worry about that. So what we're going to do for this one is we're going to click on it, click on this blend tree, and from here we're going to change the blend type from 1D to 2D freeform Cartesian, or however this is pronounced. Now, as you can see over here, it says it's trying to use the blend parameter that doesn't exist, so we're not going to use that one. Instead, we're going to use over here face X, and over here we are going to use face Y. There you go. Now, you can change the names of the parameters that you want to be used here in this blend tree, as you can see, and just changing them with the name. Or you can change them on the drop-down list over here. So we have the face X, and over here we have the face Y. And these parameters are floats, if you didn't notice. So over here we clicked and we created a float, face X and face Y. And you can see now, you see, these are those parameters. Now, these parameters, of course, need animations, which are these motions over here. So what I'm going to do is I'm going to click here and I'm going to add a motion field. I'm going to add another motion field. So we're going to have 5 motion fields. So let's go here, 3, 4, and 5. Now, for these motion fields, select the first one is going to be our player down. There we go. The second one is going to be our player up. There we go. The third one is going to be our player side. Then we're going to have the side down, and last but not least, side up. So these are the animations, and automatically over here you can see that the blend tree has now all of these animations over here. And it is going to go from one animation to another based on the parameters that we attached over here, or that we set over here. So when the position X is 0 and position Y is -1, that's when we are going to play the player 1 down animation. Then over here, when the position X is 0 and the position Y is 1, we're going to play the player up. Going back here for the side, when 1 is X and 0 is Y, over here 1 -1, and over here it's 1 and 1. I'm also going to change here the speed of these animations to 0.4 because it's going to be the same for all of these animations. And again, this is the speed of the animation. So this right here is how fast that animation is going to be played, which is basically the same thing as what we do with our state, and then we change the speed over here. So this is the exact same thing that we are doing here. Now I can double click this, and of course, as I said, so depending on the face X parameter, we are going to play or display the appropriate animation. So over here, when the value, I'm going to set that value, let's say for example it's 0, and over here it's -1, and now I can preview that. You see, we're going to preview the down animation. When here is 0 and here is 1, look at that. And when I say look at that, this is the preview of the animation. And notice when I'm changing the parameter values over here to the values that we set over here, then the animation preview changes. So there you go. So now we're previewing the up animation. So we can have here 1 and here we can have 0. And now you will notice that we are playing the side animation and so on and so forth. So you see how these animations, or how we can use a blend tree to switch between these animations smoothly, very smoothly, by simply providing these parameters that, of course, in the next video, we are going to start to tackle in our script. But before we do that, we had to prepare all of that. Now, if something is not clear when it comes to the blend trees and all of these animations, you see, that is the beauty of the blend tree. We only have one blend tree, which holds multiple animations, as opposed to us having all of these animations separated in, motions that we can have inside the Animator controller, and that's over here, so that you can, have them here into the states and motions and whatnot, and then going and activating all these different animations. That can be done as well, and it's not an uncommon way. But also here we can use a blend tree and simply, in our code, change the position X and position Y values that we are going to start doing from the next video. If something's not clear when it comes to the blend tree, ask, I will answer, and I will see you in the next video. Okay, my game dev gangsteronios, let us now create the player movements. Over here, I'm going to create a new folder, and hopefully it will create from the first try. Look at that, it did, I cannot believe. So I'm going to call it scripts, and from there, I am going to right click and create a player, or create the player script. So player scripts, there you go. Now, inside of the player scripts folder, I am first going to right click and create a script that I'm going to call character movement. So character movement. Now, why don't I call it the player movement? Well, because we are going to use this script as a basis for the movement and for the player, for the enemies as well. So it's not going to be only a script for the player, and we're going to see how that is going to go. So what do we need over here inside of our character movement? So the character movement is going to have a serialized field to first, they're going to be protected, and this one's going to be float X speed, which is going to be equal to 1, and this one's going to be the Y speed, which is going to be equal to 0.75. Now, what does protected mean? Protected means it's accessible in the parent class, or actually, excuse me, not the parent, but the child class. So we are going to inherit this class, and we will be able to access these variables, because if we make them private, these variables are not going to be accessible in the child class. And if you don't understand this, then you need to go over the basics of C# and programming in C# and specifically go through inheritance. Now, I have that in the comprehensive volume 1. But I have those videos, same videos, on my YouTube channel as well. So the C# part and all of that, I have those videos on my YouTube channel that you can watch as well. So now we are also going to have a private vector3 variable. This one is going to be our move delta, which we are going to use to, move the character. We will see that. Next, we're going to have a private Raycast hit 2D, and I'm going to call this one movement hit. Next, we're going to have a private box collider 2D that I'm going to call my collider. Now, you can assume what the Raycast hit is, because we are going to cast the Raycast. We need a Raycast, and that is, physics 2D dot Raycast and so on and so forth. So we're going to see that. Now, these two variables, the next one, private bool underscore has player target, there you go. And here, public bool has player target, there you go. These are going to be the variables for the enemy, and we will see that. So over here, we're going to have a getter that I'm going to say return underscore has player target, and here we're going to have a setter that is going to say underscore has player target is equal to the value. Now, as I said, these variables are for the enemy, because we are going to have the enemy to chase the player, and when it has the player target, we're going to say, okay, has player target is equal to true. We'll see that when we have the enemy, but I'm going to create it right now, just so that we don't come back later on, we go back and forth and all of that stuff. So when we create the enemy, then we'll go back here and create these two values. No, I'm going to do it right now. So inside of the awake function, I am going to get a reference to the collider. So I'm going to say my collider is equal to get component, and we're going to get the box collider component like that. So this is for getting the box collider. Now, this is a box collider 2D, by the way. And what I'm going to do with the awake function is I'm not going to make it private void, but I'm going to make it protected virtual void. Now, why am I making it like this? Because I want to be able to override this awake function inside of the child class, because I want to implement my own things in the child class, but I also want to call the parent class. So we want to do that. Protected virtual void will make this function overridable, which means we can create our own version of it inside of the child class. Now over here, we're also going to have protected virtual void, and this one is going to be handle movement, and this one is going to be float x and float y. So it's going to take float x and float y as parameters. Now, before I code this one, at the bottom, because it's very basic, I am going to simply create a public vector3, and this one is going to be get move delta, and it's simply going to return. So I'm going to say return move delta like that. There you go. Because we will need to get access to this value. Don't worry about that. We will see, but this is the function that's going to get us access to that value. Now over here, as I said, we have the protected virtual void handle movement. This is going to be the function, and again, it's protected virtual void, which means we will be able to override it in the child class, and we're going to use this one in order for us to move or to handle the movement of the character. So over here, the first thing that I'm going to do is I'm going to say move delta is equal to new vector 3, passing here the x, the y, and 0 for the z axis. Now we are also going to multiply the x and the y. So we're going to say multiply with the x speed, and y is going to be multiplied with the y speed, so that we actually move the player. But before we can move the player, we want to raycast or box cast. So we are going to say movement hit, which is our raycast hit that we have already created, and we're going to say that's going to be equal to physics. So physics 2D dot raycast, but no, we're going to say box cast, and I'm going to explain what box cast is. And over here, we're going to box cast from the transform dot position towards, or the size that we are going to use is my collider dot size. This is the angle. This right here is the angle by which we are going to, cast this box. Next over here, I'm going to say new vector 2, and this is the direction. So new vector 2, 0 for the x-axis, and move delta y for the y-axis. Over here, we're going to say matf absolute. So this is going to be the absolute, so dot abs. And over here, I'm going to say move delta dot y multiplied with time dot delta time. And last but not least, we are going to say here layer mask dot get mask. And over here for the get mask, we need to provide a value. Now that value is going to be called blocking. So over here, we're going to say blocking, but you know me. Now, before I proceed, of course, to explain this, you know me that I don't like to do things like that. So what we are going to do is go here and create. So let's go here, scripts, and right click and create the new folder for the helper scripts. There you go. Inside of this one, I'm going to right click and I'm going to create the tag manager one, and from there double click it and open it here, and I'm simply going to paste everything. So select all of that and paste it. Now you can pause the video right now and copy all of this, or if you followed my instructions or advice in the beginning to download the complete project, you can simply go into the project, get the tag manager class script or whatever, copy its content and paste it in yours. So this is everything that we are going to need. I am not even going to go through this because we can understand these are the tags, these are the axes, these are the animations, these are the layer mask, and all of that stuff. So as I said already, just copy all of these. So copy them and we can continue. So over here, instead of using this get mask blocking like this, instead of that, I'm going to say tag manager blocking layer mask, which is more appropriate and way better. Now we do need to do this as well. So I need to go back over here inside of Unity and I need to set the, so over here, layer add layer, and I need to create the blocking layer. So this needs to be created. I'm also going to create a blocking. As you can see over here, we have the blocking tag, which is created by import because, you know, the things that we have imported, they had the blocking tag and yada, yada, yada. You get the point. So going back over here, I owe you an explanation. What is a box cast? If I hover over it, you will notice here the box cast, it says, and why when I try to use my drawing tool, it removes it. Anyways, let's try it like this. Again, it removes it. So I need to do it like this. So as you can see here, this box cast, it requires an origin. So from where are we going to cast that box? This is the size of the box that we're casting. This is the angle by which we are casting. So is it going to be by 90 degrees, 50 degrees, whatever? This is the direction by which we are casting that box cast. This is the distance. So going here, next we have the distance and we have the layer mask. So this is the origin from our own position, basically from the position of the player, we're going to cast the box. This is the size of the box. So we're using the collider that we have attached as a size, or his size, we're using that for the box cast. This is the angle, which is, you know, understandable. Now this right here is the origin. So in which direction, or excuse me, not the origin, but in which direction? So we are going to use 0 for the X and the Y over here because we're testing, we're now moving on the Y axis. So we are testing and casting the box on the Y axis. Now this right here is the length of that cast that we're casting. So move delta y multiplied with time dot delta time, and this is the layer that we are checking if we are colliding with. So this is going to check, so this raycast is going to check if we collide with the blocking layer mask. Basically, you can imagine it, this is our player, so these are his legs, and we're casting a box, let's say on the y-axis, let's say we're casting a box here. So this is how it would look like. And of course, we will not see this in the game. This is, you know, simulated by physics. It's invisible in the game, but this is how it is going to look like, that box that we are casting. And when that box touches something, so if this right here that we touched has a blocking layer, then it will, you know, we can do the following, because right here it will return a value. So over here what I can do is I can test if the movement, so if the movement hit dot collider is equal to null, which means we are not colliding with a game object that is set to be on the blocking layer or layer mask. So if that is not the case, then we are going to say transform.translate, and we are going to move on the X for 0, so 0 on the X, and move delta Y multiplied with time.delta time on the Y, and 0 on the Z axis. So essentially with this raycast, we are testing if we are colliding with something, or a game object basically, that has a blocking layer mask. If we are not colliding, and we are denoting that by using movement hit collider if it's equal to null, so if that is true, then we are going to move. Otherwise, if it's not true, then we are not going to move. Now we are going to do the exact same thing, but on the y-axis. So over here, I can simply copy all of this and I can paste it. And if movement hit box cast from the transform position using the collider size, using 0 for the angle, but over here, instead of 0 for the X, it's going to be move delta dot Y on the, excuse me, move delta dot X. And over here, it is going to be 0, because now we're not testing for the X, we are testing, or actually not testing for the Y, we are testing for the X. Now over here for the mat F absolute value, which is basically representing the length of the cast, we are going to use X is instead of the Y. And then we're going to test the same here, so the same blocking layer. Now over here, instead of 0, we are going to have move delta dot X multiplied with time dot delta time, and we are going to simply move this or remove it and add 0 on the Y axis. So this is basically the handle movement, which is again going to check all of that with the box cast, and if not, then it's going to use the translate, and translate moves the transform by X along the X axis, Y along the Y, Z along the Z. You get the point. So it's going to move the appropriate axis with the appropriate values that we provide over here. So this is X, this is Y, this is Z. Over here, this is X, this is Y. Actually, this right here is Y, the 0, 1. So this is Y, and this is Z. Now, unfortunately, we still not or we still can't test this out, because what we need to do is go over here inside of the player scripts and right click and go into the C# or create a C# one, and I'm going to call this one player movement. And the player movement is going to be the one that is going to be attached on the player. So I'm going to simply attach it on the player, and you will notice now over here inside of this one, well, I just wanted to show you something, but I realized that I need to inherit from the character movement. So over here, instead of inheriting mono behavior, we are going to inherit the character movement, which also inherits mono behaviors. You can see over here the character movement inherits mono behavior. So here we inherit from character movement, who inherits from mono behavior, which means we can use all mono behavior functions inside of the player movement as well. But what I wanted to show you is, if I go back over here now, pay attention at the player movement over here, we have the X speed and the Y speed. We got them by inheriting them from the character movement, which is over here. Now, what do we need over here in order to test this out? Well, simply over here, we need two variables. One is going to be private float move X, and the other one is going to be move Y. That's everything what we need for us to test this out. Now, over here inside, or basically I don't have to do anything. I just need to go into the fixed update, and this is where we are going to, get the references and all of that stuff. So I'm going to say move X is going to be equal to input dot get axis raw, and over here we're going to say tag manager dot horizontal axis, and our move Y is going to be equal to input dot get axis raw and tag manager vertical axis. There you go. And from there, I'm simply going to call handle movement, which is inherited from here, which means we can call this function. There you go. And we're calling it in the fixed update, passing here the move X and passing it the move Y. And there you go. Now, why I chose the fixed update, especially because here we're using translate? Well, because if I use update, it's jittery a little bit, and you can test that out. So you can remove fixed and test it in the update. I'm not going to do that, but you can. So it's a little bit jittery. The player looks like he's having a seizure and whatnot. We don't want that. So now we can test this out. We can go here inside of our editor. And the first thing that I'm going to do is here for the dungeon level and for the collisions, I am going to set the layer to blocking, because we're testing in the code if we collide with the blocking layer, it will not allow us to move. So that is why we need to do that. Now also here for the player in the rigid body and the constraints, we are going to freeze the Z rotation, because if we don't, the player is going to rotate and have all that weird behavior and all of that stuff that you already know. So over here, I am going to hit the play button, and now we will be able to move the character. And look at that. Now, of course, the camera is not following the character because we still did not code that. We will code it, but we can move the character. If I try to go outside of these bounds, I can't. If I try to go outside of these bounds, I can't. And if I try to go outside of these bounds, I can't. If I try to go outside of these bounds, well, you get the point. I cannot go outside of the bounds because they have the blocking layer and we're testing for it. And simple as that. So we hit the blocking layer, and when we hit the blocking layer, why did I scale? Okay, it's right here. Anyways, if I hit the blocking layer, it's not going to allow me to move. And we can see, there we go. So the movement of the player is working, and that is totally fine. So voila, that will be it for this video. Of course, if something is not clear, and what is get access raw? Well, if you want to know that, you can simply use debug.log. We already covered it, but if in any case or for some reason you don't know it, just use and print out debug access raw and simply also do axes, and you are going to see the difference what they are. Now over here we are using the horizontal and vertical axis to get the input for the XY. There we go. So when we press the A, D, left arrow or right arrow key, we're going to get this input. And when we press the W, S, up or down, we're going to get this input. Over here, I have explained what we are doing. If something is not clear, make sure you ask in the comment down below. That would be it for this video, and I will see you guys in the next one. In the previous video, we have coded the player's movement. Now the player is just moving and one animation is being displayed or previewed. So we need to fix that. We need to be able to rotate the player and animate the player. Now, in order for us to do that, and I have issues talking for it to do, and there you go. So anyways, we need a private or a reference to the camera. So camera, and this is going to be our main cam. Next, we also need a private vector2 mouse position. Also, we need private vector to direction, so direction, and we also need a private vector 3 temp scale to get the scale of the player. We also need a reference to the animator, so private animation, not animation, animator, anim. Now, I am not going to, usually what I do, I create a separate class for the animation. There is no need to do that now. We can use it over here. So as I said, and what I'm preaching and talking about the whole time, sometimes the situation is different. Sometimes the best practices are not applicable in the situation that you have. So as I said, Unity prefers to have everything separated. In this situation, just creating a script for 2 lines of code, basically 3 lines of code, because we're going to animate by using this, getting a reference to the animator, and previewing or setting the float x or value x and value y, or the parameter names that we added in the animator. So there it goes, 4 lines of code. We don't need to basically create a new script for that. Now, what I'm going to do is I'm going to say here protected, override void awake, and I'm going to override the awake. Now, we need to call this base awake, and this is automatically, you know, I just hit here autocomplete for the awake. It's calling base awake. We need to call it. If we don't call base awake, it's not going to call the parent class awake, which in this case, the parent class is the, if we go here, the character movement is the parent class. So if we don't call awake on the parent class, it's not going to get a reference to this collider, and we're going to have a null reference exception. And you can test that out. Be my guest, just do it like this, and there you go. And you will see that, you know, you will have a null reference exception. So that's why we need to call base awake. Now, when it comes to the main camera, that's going to be equal to camera.main, and this is going to get the reference. You see the first enable camera component that is tagged with the main camera. There you go. This is built into Unity. This is not something I invented, okay? Now over here, we're going to say anim is equal to get component, animator component, to get the animator component. And that would be it when it comes to the components that we are going to get. Now over here, right below the fixed update, we are going to create void handle turning, or player turning, excuse me. So player turning like that. And if I can open close these parentheses, thank you very much. Also here below, we're going to create void handle player animation, which is going to take a float x and float y parameters for that. There you go. And this is basically everything what we need. So inside of our handle player turning, which is going to be called here right above the handle movement, and this is going to determine, or this is going to rotate the player based on where our mouse is. Now for that, what I'm going to do is I'm going to say mouse position is equal to main camera dot screen to world point, and here I'm going to say input dot mouse position. Now, what is screen to world point? Well, Unity has different worlds, or basically different worlds are displayed to us. Now, when we go into the game tab and when we play the game, if I hit the play button, what we see currently, this display is displaying for us the screen world. This is what we see on the screen. But if I click on the mouse button, or if I click my mouse button here, now this point on screen is not the same as in the Unity world. Unity world is here in the scene. So this is Unity's world. And the coordination is not it's not exactly the same in Unity's world and over here in the screen world. So if I click here, this point on the screen might be, let's say for the X, it's, I don't know, 1030 pixels, and on the Y, so Y is equal to, let's say, 900. So this is the coordinate for this point in the screen coordinate system. But if I go into the Unity world system over here, that screen coordinate is not the same. So here we need to, inside of our player movement, we need to convert the screen coordinate system into world system. You see, if I go here, transforms a point from screen space into world space, where world space is defined as the coordinate system, blah, 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 blah. We don't need to know this, but just know that it is converting that screen point where we click with our mouse into Unity's world point. So now when we have that, we're going to say our direction is going to be equal to new vector 2. And from here, we're going to say mouse position dot x minus transform dot position x, which is the current position of the player, mouse position y minus the transform dot position dot y. And we are going to normalize this. Now, what is this normalize? A lot of you guys have asked me, and this is the best explanation, and I have prepared it already. So I'm just going to paste it here. So vector 2 holds two pieces of information, a point in space and the magnitude. The magnitude is the length of the line formed between 0, 1, so 0, 0, x, y, and z. And the point in space. If you normalize a vector, the result is a line that starts at this here, so 0, 0, 0, and points to your original point in space. If you were to take the length of this pointer, it will equal to 1 unit. Now, this is useful if we want to know, so why is this useful? Why is normalized useful? If you want to know the direction, if the direction of the object is important for you. Now, you can pause the video and just copy this, but you will have it in the project. Now, this is important if you want the direction. If you want to know if an object, it doesn't matter how long this vector is, it's only important if he is pointing to this side, this side, this side, this side, this side, or this. You get the point. So this is what is important. And that's why we use normalize, to get the direction. Now, when we have the direction, by using all of this right here, we can simply call here handle player animation. And over here, I'm going to say direction.x as the parameter and direction.y as the parameter. And what's going to happen in the player animation? Well, first things first, we're going to take these two parameters, our float x and y, and I'm going to say x is going to be equal to matf dot round to integer and returns f rounded to the nearest integer. So it returns this float rounded to the closest integer, basically, to the nearest integer. Y is going to be equal to matf dot round to int, and here passing y. This basically means the following: if x has a value of 1.2 or 3, for example, like this. So if it has a value like this right here, and this f needs to be here. So this matf round to integer is simply going to return 1. So it's going to make x equal to 1, like that. So there you go. We need this because of our animations. So we are going to call over here, we're going to say our anim set float, and over here we're going to say tag manager dot face x animation parameter, passing here the x, and over here anim dot set float, and over here we're going to have the tag manager dot face y animation parameter, passing here the y. And there you go. Now, of course, we still need to do some other things over here, such as we need to change the scale, but we can test this out right now. So if I go in the editor and try for us just to preview what's going to happen. So let's test it out and see. So there we go. Look at that. So you see, but we have one issue. If I point here at the top, you see this is the top left corner, the player is not rotating. And if I go here, you see the player is not rotating and all of that stuff. So that's why we need to change the scale. So we can go back over here and we can say something like temp scale is going to be equal to transform.local scale. And from there, I'm going to say if x is greater than 0, so if the x that we pass over here, if it's greater than 0, then our temp scale.x is going to be equal to matf dot absolute value of the temp scale.x. Else if x is less than 0, then we're going to set the scale x to the negative value. So over here, instead of or in front of the absolute value, we are going to make sure that you see the temp scale x is equal to the negative. And we know the absolute value will make what's after it the positive. It will make a positive number out of any number, and this minus will just convert it into a negative number. And we also need to say transform.local scale is equal to the temp scale, and this is going to fix our issue. So if I go back right now, and this is nothing new, you know, we already did the same way to rotate other objects. So pay attention now. So here, look at that. So I'm at the top left, upwards, top, actually this one's top right, upwards, top left, And look at that. You see, but we are not facing this side over here. You see, this side over here, we're not facing the left one, which is a little bit, why? We're facing the right side, but I'm over here with my mouse, but we're not facing over here. Well, what we need to do is go over here. And right here, before we set the floats, we need to say x is equal to math f dot absolute value of x, and there you go. Because we did not set, if we want to look just to explain to you, if I go back over here inside of the animator, you will notice here for the side, if I click on the blend tree, for the side, we set the x to be a positive value. Look at this. X is positive, and notice here, X is always positive when we are using it. So in 3 places over here, we're using X, and it's always positive. 1, 1, 1. That's why we need to make sure it's always positive by using the absolute value, or otherwise it is not going to work. So if I hit the play button, you can also notice here how the blend tree is going to change. Look at that. So now if I face the left side, there you go. And if I face the bottom left, down, bottom right, this is right side on the middle, up right, up left, left, right, basically facing the left side. There you go. And there you go. So now everything is working. I can, you see, I can move the character, I can rotate him, and all of that stuff. So there you go. If something is not clear, make sure that you ask in the comment down below, and I will help you out how we got this. Basically, we explained we converted screen points into world points. Then we got the direction by subtracting from the mouse position our own position. And we did this for both X and the Y position. And then we normalized it, and we explained for why or for what is normalized used. So when we want to know the direction, we use normalized. And then we passed that here into the handle player animation, and we did all of these things. So we rounded these integers because we need them to be, at 1.0, not 1.2 or 3 or something like that. So we rounded them. We of course changed the scale over here, and over here we, converted X into a positive value so that we can also face the left side. And then we're calling the animator to animate all of that. Now, of course, again, if something is not clear, make sure you ask in the comment down below, and I will help you out, and I will see you guys in the next video. In situations like this, I always debate what is the next thing that I will create in the tutorial. So what is the next step? So for example, we have the player guns and stuff like that we need to create, but we also have the camera follow. And I want the camera to follow me along the level, so this is the first thing that I will create. And over here inside of the scripts folder, we're going to create a new folder. And I don't know, I can call it camera scripts or something like that, because we are also going to have a script that is going to shake the camera when we shoot. We will see that, do not worry about it. So over here, we're going to create a new C# script that I'm going to call camera follow. And surprisingly, we're not going to attach it on the main camera. Instead, we are going to attach it on the camera holder. So over here, I'm simply going to drag and drop it on the holder. And the reason for this, you will see later on, because of the script that I already mentioned, the camera shake one, it needs to be attached on the camera itself. So we cannot have the camera follow and the camera shake on the same camera, because that would look a little bit, crazy. But, we are crazy developers, so, you get the point. Anyways, over here, we're going to have a private transform, and this is going to be our player target, which, is going to be the target that we are going to follow, because the camera follow is for the player. Over here, we are going to create a serialized field, and this one is going to be private float bound underscore x, which by default, I'm going to set it to be 0.3, and bound, you can, assume it's going to be y, which by default is going to be 0.15 f. Now, of course, you can see that I set them to be serialized fields, which means they can be easily edited in the inspector if you don't like these values. Next, we have the private vector 3, and this one is going to be delta position, and we're going to have a private float delta underscore x and delta underscore y. There you go. So the first thing that we need to do is get a reference to the player, which is going to happen in the start function. I put it in the start because in the case you want to spawn the player inside of a wake function of, I don't know, some game manager, gameplay controller, because that is going to be your assignment. If you remember, I told you to create, everything what we do for this player, you're going to do for 2 other players. And later on in the game, when we create the main menu and the character selection screen, your assignment will be to create a way for your users to select any character and play the game. Well, when the character is selected, you are going to use some, gameplay controller, game manager to spawn him. So you do the spawning in the awake, and that's why here in the start, we're going to get a reference to it. So we're going to say player target is equal to game object find with the tag. And over here, I'm going to say tag manager player tag dot transform, because we're getting or looking for the transform component of the player. Now, we are going to follow the player in the late update, or if you followed any of my tutorials, I like to use late update to do the following stuff, because any calculation that will, see, late update is called every frame if the behavior is enabled. Still not enough explanation. What is the difference between late update and update? We talked about this already, is that any calculation that happens in update or fixed update is already calculated, finished, and that data is available to us in late update. So if the player has moved, his position has been calculated, he has already moved on that position, so that information will be available in the late update. So over here, the first thing, I'm going to put a barrier. So if we don't have a player target, meaning the player has been killed, we are going to return, not wrecked, whatever, return, there you go. So if the player is destroyed, we are going to return, and the reason for that is if, the player's health drops to 0, then, we will use destroy or whatever. In that case, we will not have a reference to the player target. So if it's the case, then return so that we don't get a null reference exception. Now over here, our delta position is going to be equal to vector2 or vector30, excuse me. Now, first, we are going to do a check if the bounds, so if we are inside the bounds on the x-axis. So over here, I'm going to say delta x is going to be equal to player target dot position dot x minus transform dot position dot x. So we're basically subtracting from the player's position x the current position of the camera. And then we're going to say over here, if our delta x is greater than the bound x, or if our delta x is less than the negative of the bound x, well, in that case over here, and you can understand what we are doing. So if delta x is greater than the bound x, or if it's less than the negative of the bound x, negative is basically, the opposite of the positive. I mean, that's obvious, but if the positive, the bound x is over here, and what did I do? Again with this, so annotate screen, I want the drawing part, here it goes. So if it's here, so if bound x is here, well, the negative is then over here, simple as that. So over here inside of this if statement, we are going to do another check. So if the transform position dot x is less than the player target dot position dot x, if that is the case, then delta position x is going to be equal to delta x minus the bound x. Else, if that is not the case, then delta position, or actually delta pos dot x is equal to delta x plus the bound x. There you go. Now this is if we go outside of the bound. So in that case, we're going to test if the current transform position x of the camera is less than the player target position, so less than the player's position x, then we're going to set here the delta position x, which is this one over here. It's going to be equal to the delta x that we have over here minus the bound x, which is going to make it away from the negative of the bounds. Else, if that is the case, then over here we are going to say delta position dot x is equal to delta x plus the bounds x. So if the transform position x is greater, that means the player is out of bounds over here. So we need to make him go back, over here, or basically make the camera follow the player there. So over here, next, we are going to do the same thing for the delta y, and that is going to be equal to player target dot position dot y minus transform that position dot y. And then over here, we're going to test if the delta y is greater than the bound y, or if the delta y is less than the negative of the bound y. So the same exact principle what we did right now for the x, but this time we're doing it for the y. So over here we're going to test if the transform position x, or actually y, excuse me, of the camera is less than the player target position dot y. So if that is the case, then the delta position dot y is equal to delta y minus the bound y. Else, if that is not the case, then delta position, or actually delta pos dot y, is equal to delta y plus the bound y, so that we can move the camera away from the bound on the right side. So delta position z is going to be set to be equal to 0 because we don't need it. And after that, we're simply going to say transform position plus equals to the delta position. Now, this is a little bit different way that we, use to make the camera follow the player. We didn't use something like this, the code structure, we didn't use like this. Usually we use the camera, then we find the player position, then we subtract from it some threshold and stuff like that. But this is also another and fresh way, to learn how to make the camera follow the player. So if I hit the play button now, we are going to see that we don't have, there you go. We didn't tag the player here with the player tag. So it's a good idea to tag your objects if you're, want to use their tags. So over here now, there you go. Look at that. You see how the camera is following the player, and it is using the current position of the camera, subtracting from it the current position of the player in order for us to, or in order for the camera to follow the player. Now, of course, when it gets to the bound part, it is simply moving away by the bound value. So it is moving away from the bound value, which over here is 0.3 and over here is 0.15. Now, of course, you can, experiment with these values. You can, set, 1, 2, and see the difference, but that is basically it. And if you're wondering what is the actual code, where is the camera following the player? Well, over here on the delta X, you see delta X over here and over here. So this is where it is following or making the camera follow the player. And over here, it's simply making the camera away from the negative bounds. And over here, actually, here is from the negative bounds, and over here is from the positive ones. That would be it. Now, if something is not clear, just make sure that you ask in the comment down below, and I will help you out. I don't know what was that. I'm not a singer. Anyways, and I will see you guys in the next video. The next step is to prepare the guns for the player. And for that, we are going to go over here inside of our sprites folder, and not the sounds, but the sprites again. And over here we have the weapons. So we have multiple weapons over here, but we are going to use a few, well, 4 to be precise. The first one is going to be the pistol. And you can see here at the, bottom right, whatever, you can see how small the pistol is. Now we are going to leave that at pixel per units for 100. But what we are going to do, first things first, we are going to right click on the player and create an empty game object as a child. We're going to do this for every weapon. So I'm going to go here, and this one is going to be the pistol gun. And the position is going to be 0, 0, 0, so exactly, where the player is. But after that, what we are going to do, we're going to have the side for the gun. So we're going to have the gun side, gun up. So from here, I'm going to drag the side. And this one, I'm simply going to say gun side. There you go. Now for this one, we are going to set the position of it. So click on it, and the position is going to be 0.037 on the X, and on the Y is going to be negative 0.0599. Now we don't see the gun because over here on the sorting layer, we need to set it on the player layer. There you go. Now we can see it, but I'm also going to change here the order in layer to 4 so that we know it's, exactly rendered on top of the player. I'm also going to select all of these images over here and change them to point filter and hit apply so that it will change. Look at now. So now it looks perfect. Well, perfect. It looks good, not perfect. Okay. So now moving forward, this is for the side. Now when we face the up one, so we are going to go here instead of gun side. This one is going to be gun up. And for this one, we are going to have the up texture, there you go, but we are also going to position it, so X is going to be 0 and Y is going to be 0.08. There you go. But I'm also going to do one thing, and that is change the scale, and the scale is going to be 1.2, 1.2 on the X and the Y. But for this one, we also need to make sure that the order in layer is, it's not rendered on top of the player. So the player himself, he is on the player layer, and he's going to be on the order in layer 3. But this gun up is going to be on order in layer 1, so that look at that. This is how it's going to look like. And to demonstrate that, we can go over here and we can take the player up animation and play it. So this is how it will look like in the game. You see, this is how it will look like, how he is holding the gun in the game, as I said. So next we are going to duplicate the gun up, and I'm also going to turn off the gun up, but this time we are going to have the gun down. There you go. And over here we're going to put the down one, so select it, drag and drop the down, voila. I'm also going to reposition it, so this time the gun down is simply going to have minus or negative for the y-axis, and the value on the scale is going to be 1, 1, but I'm also going to change over here the order in layer to 4 so that it is rendered on top of the player. So duplicate it, and we can turn this one off, and this one is going to be diagonal up, so diagonal up. And here we have the diag up, so simply put that, there you go. Now for this one, we are going to say the X position is going to be 0.0054, and over here the Y is going to be 0.01. So 0.01. The scale is going to be 1.3, 1.3. There you go. And the order in layer is going to be 1. And voila, this is how it's going to look like. And again, if it's not clear how, because you can see over here, here is the gun, but you can preview the animation, and that's side up. There you go. You see, this is how it is going to look like in the game. And we saw that in the preview as well. So we saw in the preview how the guns looked like. Now over here, I'm going to change this because we also have the diagonal down. This one is diagonal up, and now we're going to have the down one. And over here, we're simply going to take the diag down, voila, put that over here. Now the X is going to stay the same, but the Y is going to be minus 0.08, and over here, the scale for it is going to be 1, 1. And I'm going to set the order in layer 2, 4, and there you go. So that would be it. I'm going to turn this off, and voila, this is our pistol gun. Now next we are going to have the matter gun, so I'm going to duplicate the pistol gun and turn off the pistol gun original, and this one is going to be our matter gun. Now matter, it's not like, it matters and doesn't matter, I don't know, it's called the matter, okay? So for the matter, I'm going to select the gun side, and we are going to take the side first things first and position it here. Let me just turn it on so that we can see. And also what we need to do over here is make sure that, we set that to point, and voila, this is how it is going to look like. Now, when it comes to these, we're also going to leave the pixel per unit, so we're not going to touch that, but we are going to, rescale it. So scale is going to be 0.8, and over here for the Y is also going to be 0.8. The Y position can stay, and actually the X and the Y position are going to stay, and also the order in layer. Now, this is for the side. Let's go here for the gun up. Attach the gun up over here, voila, there you go. And of course we need to change the scale, so it's going to be 0.7 and 0.7, and voila, there you go. This is for the gun up, and also the order in layer is going to stay as is. Now for the gun down, select it over here and take the down one and put it over here, there you go. Again, changing the scale to 0.6 over here, 0.6. The Y position, X position, and order in layer are going to stay as is. So we're going to turn this one off. And from here, we have the diagonal up. So I can, turn it on and take the diag up and put it over here. And of course, change the scale. So 0.9 for the X and 1 on the Y. For the diagonal up, everything else is going to stay as is. Turn it off, and then turn the diagonal up, or actually, excuse me, diagonal down. Now for the diagonal down, let's drag the diag down. What did I do? Select it, diag down, There you go. Change the scale. 0.9 on the X, 1 on the Y, position X, position Y are going to stay the same, and everything else is going to stay the same. Voila, turn it off, and just duplicate the matter gun, turn off the original matter gun. Next we have the laser gun. So over here I'm simply going to say laser. There you go, laser gun. Now let's go into the laser gun folder. So weapons over here and laser. There you go. Select all of this and change it to point filter and just simply hit apply so that these changes, apply right away. Now over here we have the side. Let's drag the side. There you go. Here is the side. We're not going to change the scale, and position and order in layer are going to stay as is. Now I am going to turn this off and gun up now. Now when it comes to the gun up, simply drag this one over here. There you go. Now we are going to set the X to 1, and over here the Y is going to be 1.3. So 1.3. There you go. The position and order in layer and everything else are going to stay as is. And let me just turn this one off, and now we have the gun down, and let's drag the gun down. And I know this process can get tedious, but this is game development. You signed up for it. It's nothing, software development or Android or whatever. Don't think it's easier. It has these things as well. So basically this is life. So what else to say? 1 for the scale X and 1.3 on the scale Y for the diagonal up, and over here put the diag up, and there you go. Position and everything else are as is, and last but not least we have the diagonal down. So diagonal down, turn it on, diag down, position it over here. The scale is going to be 1 and 1.3. Position and order and everything else are going to stay as is, and that will be it. I'm going to turn this one off, duplicate the laser, and turn off the original laser. And last but not least we have the flamethrower gun. So this one over here is going to be our flamethrower gun. And for the flamethrower gun, of course, select it for the side. Let's go into the flamethrower. Here it is, flamethrower. It's how it is, spelled actually. Just kidding. So point, apply, take the side and put it over here. Voila, there you go. Now for the scale, it's going to be 0.6 on the X and 0.9 on the Y. Position and everything else, the order in layer and all of that stuff are going to stay as is. So I'm going to move this and activate the up one. Take the up over here, put it over here. Now when it comes to the X, it's going to be 0.6 and Y is going to be 0.8. There you go. Position and everything else are as is. Going over here, turn it off, gun down. There you go. Take the down one, put it over here. Now order in layer are going to stay as is, but over here I'm going to say 0.5 for the X scale and 0.8 on the Y scale. So this is how it is going to look like. Diagonal up. So we are nearing the end of this setup. Do not worry about that. Diag up. Here it is. Position. Everything stay the same, but the scale is going to be 0.7 over here and 1.1 over here. And that will be pretty much it. So I can turn this bad boy off and turn this one on. Diagonal down is going to be 0.7 X scale and 1 on the Y scale. There you go. Everything else stay as is, and there you go. So turn off these guns. So they are by default turned off. Do not worry about that. We will, create a script starting from the next video. We're going to start to create a script that's going to get all of these, guns, and then it's going to change them based on which gun we select and all of that stuff, yada, yada, yada. If something was not clear when it comes to this video, make sure to ask in the comment down below, and I will see you guys in the next video. Alrighty, my game dev gangsteroneos, now we are getting serious. So the first thing over here inside of our scripts folder, I'm going to right click and create a new folder, and this is going to be, I'm going to call it weapon script. So weapon scripts, and first we need a script that's going to manage all of these weapons. So it's going to manage, for example, the side of the gun, the up, the down, and all that stuff. So I'm going to right click over here and create a C# script, and this one is going to be called weapon manager. And it is going to be attached on every single one of these gun holders, so pistol gun, matter gun, laser gun, and all of that stuff. So we are going to attach the weapon manager on these bad boys, and of course double click it and open it in Visual Studio. So over here, let me just tag the class and do my thing. The weird part, we need to get over it. So there you go. What we need inside of our weapon manager is we need to hold all of these weapons. So I am going to create a serialized field of private game object array, and these are going to be the guns that we have beneath every single one of these holders. We're also going to have a private integer, not private, it's private int current gun, which is going to be the index of the current gun that we have or that we have activated. We also need an audio source, but that will come later on. Do not worry about that. So what we are going to do over here is we are going to create a function to deactivate all guns, and this is going to happen right away. So first, when we run the game, we're going to deactivate all guns. So we're going to say for int I, as long as for int I that it's equal to 0, as long as I is less than the guns.length, and then I++. Then from here we're going to say guns, and the element that's at the I index dot set active to be equal to false, and this is going to be called in the start function. So we're going to say deactivate all guns right away. Now next we are going to create, and this is basically everything here is clear. If something is not clear, make sure that you ask, but we are just looping through the array and deactivating every single object inside. Now over here we're going to say public void activate gun, which is going to be a function that's going to take an index, and over here I'm going to say int new gun index, and we are going to simply call here guns, and the element that's at the current gun index set active to be equal to false. Now next, the element that's at the new gun index dot set active to be equal to true, and then we're simply going to say the current gun is equal to the new gun index. So essentially what we are doing over here, we're deactivating the previously activated gun, and then we are activating the next gun in the array, and then we're setting the current gun to be equal to the newly activated gun. Pretty simple, because next time when we change the gun, so for example, let's say this, the current gun that is activated has an index 0 and the next gun is index 1. So we are going to deactivate the element that's at index 0. We are going to activate over here, as you can see, the element that's at index 1, and then we're going to say the current gun is now equal to this, so 0, so the current gun is not equal to 0 anymore, instead it is equal to 1. And that would be pretty much it. So next, what we are going to do, well, next we are going to go inside of our scripts folder and create a new script, because now we have the weapon manager, but next we need the player weapon manager. Now we can create this inside of the weapon scripts, or we can also put it here in the player scripts. It makes, makes sense to put it in both scripts, because it's the weapon script and it's also the player script. But I'm going to put it here in the player script folder, and I'm going to call this one player, and then I started to create a folder, so create the new C# script, and this one is going to be our player weapon manager. There you go. And this one is going to be attached on the player himself. So let's go over here, player weapon manager, and attach it. But before we do that, make sure that you select every single one of these guns, and I'm going to click the lock icon, and I'm going to attach all of these guns. So from here, simply drag and attach all of these guns. Now, the order does matter, so they are going to be side, then up, then down, then up, and then down. So that's pretty much it. This is for the pistol one. So now we're going to do that for the matter gun. So over here, lock the icon and select all of the guns and simply attach them over here in the array. Do the same thing for the laser one. So over here, lock it, select it, and then bam, there you go. Last but not least, here we have the flamethrower, select him, and then over here, select all of his guns, and then simply drag and drop these. If we, don't do this, it's, we don't do it, then, we have a problem. Okay, so going over here inside of our player weapon manager, what we need, well, we need to get a reference to all of these weapons basically so that we can control them. So, we need to get the weird part out of the way. And next over here inside, we're going to say serialize field, and this one is going to be private weapon manager array. And this is going to be our player weapons and not player weapons manager. So player weapons, there you go. And we also need a private integer weapon index, there you go. And this is pretty much what we need for, the moment. And inside of the awake, we're going to say weapon index is equal to 0, which is by default. And then when we start the game, we are going to say player weapons and the element that's at the weapon index dot game object dot set active to be equal to true. Because when we start the game, we need to initialize, the first weapon that we have. And that first weapon is going to be our, the element that's at the first index. In our case, it's the pistol. Now, we are also going to create two more functions. One is going to be public void activate gun, which takes an integer gun index so that we know which gun we are going to activate. And this is simply going to go inside of our player weapons. So player weapons and the element that's at the weapon, or actually, excuse me, the player weapons and the element that's at the weapon index dot activate gun, and over here we're going to say gun index. So I did good. I thought that I need to put the gun index over here. No, but we need to go inside of the array for the weapon manager and the current weapon that we have, the current weapon that is active, and then it needs to activate the gun on the index, which is basically over here. See, new gun, so it's going to activate the gun. Basically, this is going to activate the side gun, the up gun, the diagonal up, diagonal down. So this is what this line of code is doing. Now below it, we are going to create a function void change weapon. There you go. And this one is going to be called in the update function. So over here, we're going to call change weapon. And what's going to happen inside of our change weapon is that we are going to test when we press the Q button. So we're going to say if input, not integer, if input dot get key down, and we're going to pass here key code Q. So there you go. And if we press the Q key code, then we are going to change the weapon index. But before we change the weapon index, we are going to say over here player weapons and the element that's at the weapon index dot game object dot set active to be false. And then we are going to take here our weapon index, and I'm going to say plus plus to increment the value of it. And over here, after we do that, then we are going to activate the next one. So over here, we're going to say true. But before that, we need to make sure that we don't go out of bounds of the array. So for that, we're going to say if our weapon index is equal to player weapons dot length, then we're going to say weapon index is equal to 0. So this is essentially what is happening over here. Now let me elaborate or explain. So when we press the key code Q, then we are going to deactivate the previous weapon. So the weapon that's at the current weapon index, we are going to deactivate. Let's say we currently have the weapon that's at index 0. So when we press to change the weapon, meaning now we are changing to the element or the weapon that's at index 1, first we are deactivating the element that's at index 0 because the weapon index still has a value of 0. Now over here, we increment the value of the weapon index, which will make it have a value of 1. And then we're going to activate over here the next weapon index. There you go. So now we're activating the weapon index that's on the weapon that's at index 1. But before that, we need to make sure that we don't go out of bounds of the array. So we cannot say weapon index plus 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 every single time without testing if the weapon index value will eventually get to the point where it's the same as the length of the player weapons, which will essentially make it, you know how it goes. These are arrays. So we will have exactly, or the weapon index will be the exact value as how many elements we have in the array. And that will throw a null or array index out of bounds exception. And this is happening over here in the update. Now we are still not done because this is not going to change. This is not going to display the weapons. Instead, what we need to do, we need to go into the player movement. And over here, after we get a reference to our anim, we need to say private, and we need to get the player weapon manager that I'm going to call player weapon manager. There you go. And we need to get a reference to it. So that's going to happen over here after we get reference to the animator. So player weapon manager is equal to get component that is attached on the player, which is the player weapon manager. So now we have a reference to the player weapon manager. And in order for us to activate, what we need to do over here, we need to create void activate weapon for side, which takes a float x and a float y value. And this is going to be called right here below after we animate. So over here, we're going to call this function, passing the x and passing the y values. So why or what the hell is this, teacher? Activate weapon for side. Well, we saw that depending on the side where we are, we need to have a weapon for that side. So we cannot be like this. So I can go over here and I can show that. We cannot be, for example, if I take the player and we look down, we cannot look down, so the downside, but have over here activated the side gun. You see how it's going to look like. So the gun is facing this side, the player is going down. When we shoot, it will shoot in this side. And look at how it looks like. So it looks, it looks how we don't want it to look. Simple as that. So that is why we need to activate the weapon that, for the current side. And this is the function that's going to do that for us. So over here, we are going to test or perform a few tests. So we are going to say, if our x parameter that we passed over here is equal to 1f, and our y parameter is equal to 0f, then we are going to call the player weapon manager, and over here player weapon manager dot activate gun at the 0th index. Next, moving forward, and this is for the side, by the way. So this one is for the side. Next one here is for the up. So over here, we are going to test if the value for the x is equal to 0 and value for the y is equal to 1, then we are going to activate the element that's at index 1. So now we're going to do that for the down. And over here, I am going to tag it with down tag. So if x is equal to 0 and y is equal to -1, then we're going to activate the element that's at index 2. Now we have the side up. So over here, side up, and that is if x is equal to 1 and y is equal to 1, we're going to activate the element that's at index 3. And last but not least, here we have the side down, and I'm going to paste this over here, and that's going to happen if our x is equal to 1 and y is equal to -1, we're going to activate the element that's at the 4th index. And that's going to happen over here simultaneously in the handle player animation. Now, let me demonstrate this. And after that, we will, go back and revise the code again. So if I hit the play button, now we are going to see how the player, and we have the index out of bounds exception. Let me see what is the activate gun. So, oh yeah. We actually need to, drag all of these player weapons inside of this array, for this to work. Otherwise, it's not going to work. So that is, the lesson for this video. Now I'm going to drag over here all of these, and they need to be in this order: pistol gun, matter gun, laser gun, flamethrower gun. So this is the order how we need to drag these. So again, pistol gun, matter, laser, flamethrower. Same as how we put them over here. So if I hit the play button right now, we are going to see, we're looking down and the gun is down. If I go over here, look at now, the gun is looking, look at that. You see? Now we are down. This is the diagonal down, diagonal up, up. And if I press the Q key, there you go. We changed the weapon. Another time Q, another time. Look at that. So we are changing the weapon. Look at all of that. So you see, based on where we are being rotated, we are activating the gun. And you can go over here and look at the ones that are being active. Currently, we have the side. Now we have the diagonal down. Now we have the down. Diagonal down again. Side. Diagonal up, up, diagonal up. You get the point, you see? And this is for every single one of these weapons. So let's go here and revise the code again. Inside of our weapon manager, we are simply getting a reference to all the guns, and the weapon manager is being attached on one of these or every single one of these. And as I said, he is being attached on the gun holders, and he has a reference to all of the guns sides. So side, up, down, up, diagonal down. So you can see over here, he has a reference to all of that. And this is what this script is for. So over here, we have the current gun, which is the index for the current gun that is active. And when we start the game, we're going to deactivate all the guns. Now you can deactivate them. What we did that as well. So we press the deactivate and, the checkbox to deactivate the object. As you can see over here, they are all turned off. You can see they're all turned off, but this is just a precaution. Maybe, sometime you'll go back, update your game, you forgot to deactivate, you were testing some guns and stuff like that. You forgot to deactivate them, it can lead to problems. So we can deactivate them here. And this is a function that is going to deactivate the previous gun, activate the new gun, which is basically the gun side. So it will deactivate the previous gun side and activate the new gun side and set the current gun to the new gun index. We explained that. So after that, we have the player weapon manager who manages all of this. So he manages all the objects holding this script. And if we go back over here in our editor, we will see that the player weapon manager has the reference to all of the objects who have the weapon manager script. So he also has an index to activate, the different weapons. When we start the game, the first weapon that's going to be active is the pistol. So this is what we are doing over here. So we're activating the pistol game object holder. And over here, we have the change weapon function that is going to allow us to activate or actually change the weapon. So do we want the pistol, the matter gun, the laser, or the flamethrower gun? So this is what we are doing over here. So we're deactivating, for example, the gun holder, then incrementing the index, checking if it's out of bounds. If it's not, activating the next one in the row, which will be the laser or the matter or the flamethrower, or going back to the weapon. Now this right here is going to activate the gun side for the current weapon or the current gun that we have. So if we have a pistol, this function is going to activate the side of the pistol or the diagonal up or the diagonal down or up. You get the point. So this is the function that it's doing that. And this is the function that we are actually calling in the player movement. So this right here. So we got a reference to the player weapon manager. And then over here, based on the animation, because this is how we are facing the sides with the player by using the animation. So we are either facing the side, diagonal up, up, down, diagonal down. You get the point. So over here, we're activating the weapons for the sides. And depending on if we are on the side, that is when X is 1 and Y is 0. And how do I know this? Well, basically, it's, in the animation. So over here, you will see, look at that. So when we are on the side, X is 1, Y is 0, which is over here. X is 1, Y is 0. If we are up, over here, up, Y or X is 0, Y is 1. X is 0, Y is 1. If we are down, over here, down, X is 0, Y is minus 1. So X is 0, Y is minus 1. You get the point. So depending on the side that we're facing, we're activating the guns or the appropriate sides. So the side is at index 0, up is index 1, down is index 2, side up is index 3, side down is index 4, and you get the point. And this is done automatically over here inside of the handle player animation. So depending on the facing, so if we're facing the side, the up, the down, you get the point. We're simply passing X and Y. Based on their values, we're activating the sides of the guns, which will result in this right here. So there you go. So now, depending on where we are facing and depending on which gun we have, it is activating the sides of those guns. Look at that. So there you go. And voila. Now, if you have any issues, if so, and over here, you see, I need to change this for the diagonal down. Look at this for the flamethrower. So we need to go here inside of our assets, sprites, and weapons. Flamethrower for the diagonal down. Here it is. We need to change this one diag down, which is basically the flamethrower's diagonal down. Let me just check it and see if everything is okay. There you go. So now everything is okay. I was using the laser ones, and voila, all of these now weapons work. Yeah, everything is in order. So if something is not clear when it comes to this video, just make sure that you ask in the comment down below, and I will see you guys, in the next video. I'm not going to hop at your home and see you there. No. And I don't live in the same country as you do, so I'm not going to see you on the street. I'm going to see you in the next video. Take care. What up, gamesters, or whatever? Now, moving forward, we are going to prepare the bullets for our guns, and that's going to happen over here inside of the sprites and shooting in bullets, and there you have the bullets sprite sheet. Now, of course, we need to change the sprite mode to multiple from single, and also change here the wrap mode to point, and let me just hit apply, and let's go over here, and here we have multiple bullets, so you can choose, on your own, whichever bullet. So I'm going to choose this one. This is going to be the pistol bullet, so I'm going to not slice all of these, but just slice the bullets that I need, because I don't want to go through all that mess and search for the bullets. So this one is going to be the pistol bullet. There you go. Now moving forward, this one right here, I'm thinking this one or this one. And this one over here is going to be the laser bullet, I believe. This one is going to be the laser bullet. So laser bullet, there you go. And it's not lowercase than uppercase or uppercase lowercase, whatever. It's laser bullet over here. Actually, this is the matter, excuse me, the laser is over here. I know I missed something. So the laser, I'm thinking what or which one should we use? So this one is the matter. So let me just go here and say matter. Not matter, it's matter, man. There you go. This one over here is the fire one, and I'm choosing the fire one or the flamethrower one before I decide which one I want to use for the laser bullet. So this one goes over here and goes over here. This one is the flamethrower bullet. There you go. And last but not least, I'm still thinking, so which one should I use for the laser? Blue or this one? This one, I believe. So this is the one that I'm going to use for the laser. There you go. Let me just move this a little bit over here. And this one is the laser bullet. Voila. Simple as that. And hit the apply button so that these changes apply to the prefab and, whatnot. So now we are going to go over here. And this is the flamethrower, this is the laser, the matter, and the pistol. So I'm going to select all of these and I'm going to set them on the bullet layer so that we can actually see them. And as you can see, they are, high, or they are, large. So taking the pistol bullet, here it is. I'm going to apply on him a circle collider. There you go. But we are also going to have an animator for all of these. So I'm going to attach an animator, not an animation. We will see what we're going to do with the animator. It's going to be really cool. So Animator, and I'm going to move the component up. This one is going to be a trigger. There you go. And it's also going to have a rigid body. So rigid body, and the rigid body is not going to have any gravity scale. So we're going to set that to be equal to 0. And also over here, we're going to freeze the Z rotation. Now I'm also going to change the scale, as you can already assume. So 0.4, 0.4. This is the scale for the pistol. So next we have the matter. It's the same process. I'm going to select all of these and attach the animator. So animator component, because we need to attach the animator on all of these. So for the matter, I am going to set a box collider. So here, a box collider 2D. It's also going to be a trigger. Now you can also change the size of the box collider. So something like this, it will be a little bit smaller, but that is up to you. It doesn't have to be, it's not that important. So there you go. Now I'm also going to attach here a rigid body 2D. There you go. Also make sure that the gravity scale is set to 0 because we don't want gravity affecting this. And over here, 0.4, 0.4. There you go. This is the bullet. So next we have the laser bullet. And as you can assume, the same exact process. So for the laser, I'm also going to use a box, and it did not attach the animator Animator. Why didn't it attach the animator component? Anyways, attach the box collider. There you go. Make him a trigger. This is enough for it. There you go. For this one, rigid body 2D. And over here, freeze the Z rotation. Gravity scale is 0 and 0.4. So 0.4. There you go. For the scale, that is. Last but not least, we have the flamethrower. Here he is again. Attach the animator component. For whatever reason, it didn't attach. So we have the circle collider. There you go. Set it to be a trigger. Attach the rigid body. Voila. And gravity scale 0. Freeze the Z rotation. Set the scale to 0.3, and I think that would be it. Now what we also need to do is go over here for the tag and create a bullet tag. So bullet, and tag all of these with the bullet tag. So tag them with the bullet tag, and we're not going to touch any layers and whatnot. Don't worry about that. But what I'm going to do is go over here and create prefabs for the bullets. So, and sometimes the folder is not going to be created from the first try. So bullets, and or actually bullet prefabs. So bullet prefabs, and inside over here, I'm going to right click and create a folder for the player bullets, because we're also going to have the enemy bullets, so player bullets. And we need to drag all of these. But before we do that, well, actually we can do it right now. So drag and drag and drag and drag. I don't know what that is. So going here in the scripts, I'm going to right click and create a folder, and I'm going to call it bullet scripts. And inside of the bullet scripts, of course, right click and create the bullet script. There you go. Now going over here inside the prefabs, let me select the bullets here and attach the bullet script on all of these. So bullet, this way I don't have to attach them over here and then go through every single one of these bullets and, you know, the bullet prefabs, that is. Did it attach it on the flame? Why? It should be attached on the, I have attached it on there. Okay, laser has that. Flamethrower. Why? I don't know. I selected all of these. Why didn't it attach on all of these? Okay. So there you go. But why isn't this reflecting over here? Okay, matter has it, bullet has it. Now they have it. But a moment ago, I thought that these don't have the script. Anyways, moving forward, there you go over here. Let me just, do the thing, class and tag everything and all of that stuff. You already know the drill. So what's going to happen inside of the bullet class? So what do we need for the bullet? Well, we need a private rigid body because we are going to use that to propel the bullet. And I'm going to call it my body. My awesome body, of course. Now we also need the movement speed by which, or the force by which we are going to propel it. So it's going to be a private float, move speed by default 2.5. I set it to be a serialized field because of course you can change that value inside of the inspector. Over here we're also going to have a serialized field, private float, damage, amount. By default, damage amount is 25. We can change that whenever we want to change it. Over here, we're going to have a private bool dealt damage. This is going to determine if we dealt damage or if we didn't deal damage to the player. So don't worry about that. We will see that later on. Next, we are going to have a private float, and this one is going to be our deactivate timer, and that's going to be equal to 3F because when we shoot the bullet, the timer, or we are going to start the timer for deactivation. So if the bullet misses the enemy, it doesn't get deactivated by any obstacle or whatnot, then we need to deactivate it on our own. Now over here, I'm also going to create a private bool, destroy obj. Now this one is going to denote if you are going to implement pooling or if you're not going to implement pooling. So if you are going to implement pooling, we're not going to make this variable true, because if it's true, then we're going to destroy the game object, and of course we're not going to do pooling with it. But if we're going to do pooling, then we are going to deactivate the game object. That is the difference. And we are going to do pooling, but I'm just showing you, how you can have all of that functionality in a single script. Now over here, I'm going to create the awake function, and inside we're going to get a reference to my awesome body from the Mr. Olympia, and over here get component rigid body 2D component. And also we are going to get a reference to the animator here, so get anim, but that will come because we're not going to do anything with the animator inside of this video. Now over here we can invoke, so we can call the invoke to call the function that is going to deactivate bullet, and it's going to be deactivated in the deactivate timer manner. Now over here we can create that function, don't worry about that, so we're going to create it. Later on we are also going to change a few things in this script, but don't worry about that, we will come to it. We're currently preparing everything, then we are going to shoot the bullet, and then we are going to do all of that stuff. Now over here I'm going to create a public void move in direction, which is going to have here vector3 as the direction, so direction, there you go. And over here we're going to say my body.velocity is going to be equal to direction multiplied with the move speed, and this is how we are going to propel the bullet. Now inside of the deactivate, and of course you can see it's a public one, which means we will be calling this from another script when we, start shooting, of course. So move in direction, there you go, my body velocity, direction, move speed. Now when we are in the deactivate, if, and this is what I was talking about, if we should destroy the OBJ, then we are going to call destroy over here game object. Else we are simply going to say game object set active to be equal to false, because depending on if we are using pooling or if we are not using pooling and all of that stuff, so that would be it. Now over here we are going to have void on trigger enter 2D, and we're going to test if we collide with different, things inside of the on trigger enter. When I say different things, because we are going to test if the collision compare tag, not composite, it's compare tag manager. We're going to see if we collided with the enemy tag, or over here if we have collided with the shooter enemy, so shooter enemy tag, or over here we're going to check if we have collided with the boss tag. Now the reason for that is because we are going to deal damage to the boss, we are going to deal damage to the shooter and the other enemy and all of that stuff. And over here we're going to test if the collision.compare tag, and we have collided with the tag manager blocking tag, and not blocking layer mask, but it's the blocking tag. So we collided with the game object that has the tag blocking. Then of course we are going to deactivate, destroy the whatnot, the bullet and all of that stuff. Now this is for the preparation of the bullet. This is everything that we need for the moment. We will, of course, as I said, add an animator and all of that stuff. Do not worry about that. Now, before we proceed to test all of this, here in the player weapon manager, right below our weapon index, we are going to create a serialized field of private game object array of weapon bullets. And here we are going to attach all of those, weapon bullets. So let's go back inside of the Unity editor. And of course, we're not going to do anything with these. And I don't think there is nothing to be saved. Yes, it's not. So remove these. And for the player, we need to attach here the weapon bullets. Now they are going to be in this order. So let's go into the player prefabs, select it. So first things first, we go with the pistol bullet. So the order is important so that we know in the code which, bullet to spawn depending on when we shoot with which gun. So next we have the matter bullet, then we have the laser bullet, and then we have the flamethrower bullet. Basically, this list will go from down to up. So pistol, matter, laser, and then flamethrower bullet. That is the order. It's really important that you have this order. Otherwise, it is not going to work. Now, of course, we are also going to have the bullet spawning point for our player. So over here, I'm going to right click and create an empty game object. And I'm going to call this one bullet spawn point, which we are going to use as the spawning point for the bullets so that we know from where we are going to shoot. Basically, that would be it. And yeah, that will be for this video because I don't want the videos to get too long. Some videos need to get long, but some videos can be, or some parts of the game can be broken up into, parts. And this is the part 1 for preparing the bullets. I will see you guys, and something is not clear, make sure that you ask in the comment down below. But don't worry, we are also going to revise again everything here with the bullet. So we'll come back, and of course these are just variables, everything is clear. But over here for the move in direction, that we're using direction to multiply with the move speed, we're going to calculate that over here. So that is where the calculation is going to happen. So don't worry about that. That will be it. If something's not clear, I will see you in the next video. In the previous video, we created the bullets, the bullet script, and we also attached the bullets over here in the player weapon manager. Now, there are also a few more variables that we need to create inside of this script for the shooting to work. And one of them is private vector 2, and this one's going to be our target POS. It's short for target position, or basically where we are going to shoot. Next, we are also going to have a private vector 2 direction, which is the direction where the bullet is going to go. A private camera, so camera, and this is going to be a reference to the main camera, so I'm going to call it main cam. Next, we're going to have a private vector 2, and this one is going to be the bullet spawn position. Now, while I am at it, so for the bullet spawn position, we also need to change its position. So let's go over here. And this is our bullet spawn position, so this one right here. And I'm waiting for Unity to compile everything so that it allows me to, click. So there you go, this is the bullet spawn position. Currently, the position X, Y, and Z are 0, so we need to set the X at 0.12, and Y needs to be minus 0. So minus 0.057. This is where we're going to place them. And basically, this means that it is going to be placed if I take, for example, one of the bullets. Actually, player 1 side, I need to take, let's say over here, the pistol gun and the side over here. There you go. So if I select the bullet, you see where the spawning point, it's right here. So this is where the spawning point is. And it will be like that for every single weapon. So what I'm going to do here is turn this off. And now we are good. So this is good right now. We can go back inside of our script. So here we have the bullet spawn position. And don't worry, we're not going to attach this here. We are going to calculate it and we will see how. Next, I'm also going to have a private quaternion. And this one is going to be the bullet rotation. So this is going to be the bullet rotation. So what is the next step? Well, first over here inside of the awake, after we, set the player weapons and the weapon index to be active, we also need to get a reference to the main camera, which is going to be equal to camera main. And this is going to be the, main camera, the first one that is tagged with the main camera tag. Now over here below the change weapon, we are going to create a public void. And this one is going to be shoot, which has a vector 3 spawn POS. Like that. And what's gonna happen over here is that we are going to shoot, for example, if the player is here and our mouse is here, so the player is going to shoot towards that direction. So we are going to say here target POS is going to be equal to main camera dot screen to world point, and we're going to get the input mouse position. So this is going to be the input or the mouse position of the mouse on the screen. I'm also going to take here and create the bullet spawn position, which is going to be equal to new vector 2. But over here, I am going to take the spawn position X and spawn position Y, which is the parameter over here that we are going to, pass inside of this function. So we are going to create the bullet spawning position by using the X position and the Y position of the parameter that we have over here. Next, we are going to calculate the direction, which is going to be equal to our target position minus the bullet spawn position, and we're going to normalize that. And we already explained what is normalized. So basically a vector is either a point or a direction, and we, talked about that. So for example, I'm going to take the notes over here that I have. So vector is either a point or a direction. Vector 0, 0, 5 is a direction of 5 units along the z-axis. So it has a length of 5. If you normalize that, it's vector 0, 0, 1. You would do this when you only want the direction and don't care about the length. So we normalize when we want to know the direction and we don't care about the length, as we already talked about. So over here, our bullet rotation now is going to be equal to quaternion.Euler. And we don't care about X, we don't care about Y, we only care about Z. And we're going to use mathf etan2 or etan or however it is pronounced, and over here we're going to pass a direction y and the direction x, and from there we're going to multiply this with matf radians to degrees. So this is going to convert, this right here is going to convert the radians into degrees. And what is matf etan2? Well, matf etan2 is used to calculate the angle between 2 points. And how does it work is basically, let me just show you here. I found a really good example here on Unity forum. So over here, as you can see, it gets the angle clockwise. So it's the measure of the angle counterclockwise. Excuse me, I said clockwise, but counterclockwise of a vector. So it's used similarly to etan. Okay, this is not important. What's important is that we understand it's using an angle counterclockwise or calculating that angle. And that's why we are getting over here the direction y. And over here direction x. So also if you go inside of documentation, you see just a small fix. Okay, not here. Let me just find, okay, coordinates are generally given in x and y, etc. The documentation for etan2 linked in the post states the function takes float x and float y. So that is one of the reasons why you should from time to time read the documentation. Other than that, don't. You can just pause the video and copy this link, and then you will be able to see this on your own. But essentially, if you are wondering how did I come up with this, how did I come out to use it, well, I didn't. I just searched on Google how to, how to measure an angle, how to make a bullet, fire in that direction, and this came up. I don't have to know in depth how this works. I just know the basics, how it works, and it returns radians also over here. That's why we multiplied with radians to degrees to convert the value that we pass over here that will be calculated to convert it into degrees. So now what we can do is we can simply instantiate a new bullet. Now over here, I'm just, we will remove this later on. Don't worry about that. So we need to create a serialized field, a private game object, and this one is going to be I'm going to call this one bullet, I believe. Yeah, this I'm going to call it. There you go. Or actually, we also need to get a reference to the bullet, which is over here. So we already have those bullets. I wanted to use only one for this example, but we already have them over here. So instead of, using them like this, what I'm going to do is simply go over here and we are going to say game object new bullet. I wanted to use only one bullet for this example, but we are going to use all of these bullets. Don't worry about that. So we're going to instantiate over here weapon bullets and the element that's at the weapon index. So weapon index, there you go, comma, passing over here the spawn position, and comma, passing the bullet rotation. There you go. And below over here, we need to say new bullet, and we need to get the component, which is the bullet component from here, and move in direction to pass the direction over here. Because if you remember, inside of the bullet, we have over here a function, move in direction, that's going to use this direction to multiply with the move speed, and that will be the velocity of the bullet, which, I said that we are going to calculate this. We're also going to make some changes for the bullet over here. Do not worry about that. That will come. But what's important to know is that we are passing the direction that we have calculated over here. And the direction is calculated by using target position minus the bullet spawn position. That's how we get the direction where we want to, shoot this bullet. Of course, this is just for the current example. We are going to change this because we are going to use a pooling system. I will create that. Don't worry, it's not going to be an assignment. But anyways, you get the point. Now, we are not going to test this with this functionality or with this script. Instead, we need to go here inside of our player, so scripts and then player scripts, and right click over here and create a new C# script. And this one is going to be player shooting manager, who is going to be attached on the player himself. So just select the player and player shooting manager. There you go. And double click this bad boy, open it over here. And again, the drill and all of that stuff, I don't even have to mention it. So over here, we are going to have a serialized field. One is going to be a private float. So private float shooting timer limit, which is going to be equal to 0.2. So every 0.2 seconds, we are going to be able to shoot. Private float shooting timer. And then we are also going to get a reference to our, so serialized field, private transform. So it's transform bullet spawn POS. And then we're also going to get a reference to player weapon manager, like that. Now, this is it for now. We will come later on for this because we will also get some other components and all of that stuff. But don't worry, for now, inside of the awake, we can get a reference to the player weapon manager. So I can safely say player weapon manager is equal to get component player weapon manager. There you go. For the spawning position, we do need to go back inside of the editor and attach by dragging and dropping it. So here it is. So simply drag and drop the bullet spawn position. And now we are going to create a function that's going to be called in the update. So over here, we're going to say void handle shooting. Let me just, open close parentheses as I should. So handle shooting, which is going to be called in the update because we are going to test for input and we are going to test when we press the mouse button down. So if our input dot get mouse button down, so if we press the mouse button that's at the 0th index, meaning the left mouse button click, and if the time is greater than the shooting timer, so now we are able to shoot. But when that happens, the first thing that we are going to do is strict the shooting. So we are going to say shooting timer is equal to time plus the shooting timer limit so that, the player doesn't shoot a gazillion bullets, at the same time. We are also going to call here an animator to animate. So animate muzzle flash, but that will come, don't worry about that. And over here we're going to call a function create bullet that we still didn't create, so we also need to create that function. So over here below we are simply going to say void create bullet, and this function is going to have one line of code, which is player weapon manager dot shoot, passing here the bullet spawn position dot position. Now, of course, we can also omit this from here and we can use this. That is totally legit as well. But depending on what you want to do, you might have a function for that to group the code and all of that stuff. So yeah. Anyways, when we call here handle shooting, when we press the mouse button at the 0th index, left mouse button click, and if the time is greater than the shooting timer, then we are going to call all of this here, which first is going to set the shooting timer to the new time limit. As I said, it's 0.2, which is going to allow us only to shoot 5 times in a second, which is a lot. So 0.2, actually no, 3 times in a second. Why I thought that a second has a 100, milliseconds. Anyways, so there you go. Anyways, it is going to allow us to shoot every 0.2 of a second, and then we're going to shoot, every 0.2 of a second so that we don't, shoot a gazillion bullets, but that's your preference. You can, set it to whichever value you want. After we set that, we're going to animate the muzzle flash, which still is not created. We will create it. Don't worry about that. And over here, we're going to call the player weapon manager to shoot. Who is going to shoot? So now we can go inside of our editor and we can test this out. Now, before we do that, over here for the tags, make sure that you create the enemy, boss, and shooter tag because we are testing inside of the bullet script. I almost said editor. Inside of the bullet script, we are testing if we collide with game objects that have one of these tags. So if we don't define them, we will have a null reference exception that we didn't define these tags and all of that stuff. So just to avoid this, I just, created these tags. You can pause the video, add the enemy, boss, and the shooter enemy tag. So if I hit the play button right now, we will see that when we shoot on the side, everything looks perfect. Look at that. So we're shooting all of these bullets. It looks amazing. Over here, it works and all of that stuff. But if I shoot upwards, you see, from where I'm shooting. So if I face down and shoot, look at from where I'm shooting. I'm shooting from here, from the side. I'm not shooting from here, from basically the opening of the weapon. But teacher, you said we changed the position. Look, don't cry, man. You're a grown-up, do not cry. Or maybe, I don't know, maybe you are a minor watching this tutorial, which is fine, you can cry. But, if you're a grown-up, just kidding. Anyways, what we need to do, or what is the solution? Do you know? Do you know? Pause the video, try to solve this on your own, how we can use one spawn point for all bullets and all weapons, and get away with it. So I'm going to show the solution. So at the moment over here, I'm going to put everything at 0, 0, and we need to go into the animation. And for every animation, so every side where the player is facing, I am going to animate that property. So essentially over here for the down, we need to click on add property, go here into the bullet spawn point, the transform and position. So for the position over here, we are going to add 0.002, and for the Y, it's going to be minus point or 0.15. Now also what you need to pay attention is over here, and I don't want the circle over here, you see, you want to remove these keyframes, because when we click here add property, it adds keyframes here and here. You need to remove these keyframes or otherwise it will not work. We only need the keyframes over here. So next we have the side. So let's go here on the side and click on add property, and here bullet spawn point and the transform, and click on the plus. Make sure that you remove the keys from here, and only the keys that we need are here. So 0.12 of a second, and or actually 0.12 of the position, and minus 0.057. There you go. So this is for the side. Now the side down over here, again, add property, bullet, transform. There you go. There you go. It glitched for a moment. Remove the keyframes at the end. There you go. And over here, we're going to say 0.07, so 007 minus 0.12. And this is X and Y. You can always just, copy these positions, which is what you also need to do. So over here, click on add property, bullet, transform or spawn point, then transform, then position. There you go. Remove the keyframes over here at the bottom, and 0.08 and 0.09. So X is 0.08, Y is 0.09. This is for the side up. And last but not least, over here, we are going to have up. Again, add the property, and I know some things are tedious, but again, I explained this is game development. This is what you are getting yourself into, but it's worth it. We're having fun. So 0.003, and over here 0.16, and voila. So now we have, and just again, make sure, double check that the other keyframes that we have here at the bottom are removed. So we only need these keyframes. So now that we have all the keyframes in place, we can hit the play button, we can shoot. Look at that. So now it is shooting accordingly where we are. Look at this, you see, and it's shooting towards the mouse position. You see, it's shooting towards where the mouse position is. And you will also notice that the bullets are being deactivated after 3 seconds. You can see them over here inside of our hierarchy. They are cluttering up inside of the hierarchy. That's why we're going to use, pooling, and that's not the first time. We did this a lot in the comprehensive volume 1 course. I gave you assignments for that. We did this inside of this volume 2 as well. So there you go. Look at this. It's shooting, and all of the different bullets are shooting. Look at that. So we have the different bullets, and over here you see different weapons are shooting different bullets. And what's important is that they are coming out of the appropriate, they are coming out from the appropriate bullet hole, so to say. Now we are also going to go quickly over here inside of our bullet, and over here we're checking for the blocking tag. So when we call or when we collide with the blocking tag, we are going to animate the bullet destruction, but it's going to be like, it has, how is that effect? I don't know. It's like, it goes, it's big and then small and then goes small, and then it disappears. This is what we are going to do. So that's why over here, we're not going to use destroy, or we're not going to use here this deactivate bullet or whatnot, because when we call that animation, then we are going to call this deactivate bullet, and the animation is going to deactivate the bullet when it ends playing. So that is one thing that we are going to do. But first things first, we're going to create the pool of bullets. Then we're going to create our muzzle flash and the bullet and all of that stuff, the bullet effect, so on and so forth. So if something was not clear in regards to this video, what we did, especially over here, if something is not clear, and yeah, that would be it. I will see you guys in the next video. Okay, my game dev gangsteronios, now that we have the player basically programmed, he's moving, shooting, and all of that stuff, let us start with our enemies. And the first thing that we are going to do is prepare the enemies and their animations and all that stuff. So let's go over here inside of the sprites folder, and over here we have the enemies. So we have all of these, big demon boss, devil, and whatnot. We are going to prepare these four first. So iZombie, Imp, Masked Orc, and Swampy. So if I go here, you will see that we have different animations. What I'm going to do first is select all of the animations and set them to point over here, which is for the filter mode, so that they look, more pixelated. Let's do that for all of these. So I'm doing it for the iZombie, now the Imp, enemy over here, masked orc. Basically, we can do it for all enemies. So let's go over here, point and hit apply, just so that I don't forget, you know, when I start to create enemies and all of that stuff and the bosses, and I forget to do that, or, you know, again, every single time we do for some of these, then we will go and we are like, okay, do it for this one, for that one, and so on and so forth. So this one is on point, and yeah, that will be it. So the first one is going to be our ice zombie, and I'm going to place him right here. Now, when it comes to the ice zombie, let me just select him here, give him ice zombie name. Of course, we are going to give him here the enemy sorting layer so we can actually see him. We do need to set him on the enemy tag, so just so we don't forget to do that. We are also going to attach an animator component on him, so animator. There you go. So we have the animator component. We also are going to attach a box collider. There you go. And of course, I am going to resize the collider a little bit. So click on him, maybe over here, something like this can do. This is going to be his box collider. There you go. I'm also going to attach a circle collider. So circle collider 2D, and the circle one is going to be the trigger. And we will see later why. So circle is going to be the trigger. The radius for the circle is going to be 0.09. So just a little bit, you know, it can also be, I believe, 0.1. Anyways, just set the circle to be the trigger, and we are also going to attach a rigid body. So let's go over here, rigid body, 2D, make sure that the body has gravity scale set to 0, and make sure that you freeze the Z rotation. So going back over here, we have the imp. I'm going to import all of these enemies first. So next we have the masked orc, and last but not least, we have the swampy. So I'm going to select all of these and set their sorting layer on the enemy. There you go. Now this imp, I'm going to rename him to imp, masked orc, and swampy. So this is, you know, just for renaming purposes and whatnot. That would be it when it comes to this one. I'm going to select all of them and tag them with the enemy tag and attach an animator component on them. So we need to attach the animator component. I'm also going to attach a box collider on all of these. So box collider, a circle collider as well. So circle, not vertical, it's circle collider, who is going to be a trigger. And last but not least, a rigid body 2D, which is going to turn off the gravity scale and freeze the Z rotation. We do need to change the size of the box collider. So something like this for the imp. There you go, over here. That can do. Now when it comes to the circle collider, we are also going to reposition it just a little bit. This is for the imp. So I'm going to position it at 0.0035. This is for the X, and for the Y, it's minus 0.3. There you go. And the radius can stay as is. Yeah, the radius can stay as is. Maybe I will change it later on. Don't worry about this. We will see what is the radius, why we're going to use it, and all that stuff. For the masked orc, let me just click here on the box collider editor and change the size just a little bit. There you go. I believe this is okay. For the circle collider, it can be position X 0.01 and position Y is going to be minus 0.015. There you go. For the moment, radius can stay at 0.1, but maybe later we will change it. Now, when it comes to the swampy, let me select him, and over here for the box collider, just change the shape a little bit. Same as what we did for all the enemies. There you go. And when it comes to the circle collider, it can stay as is. Maybe I will change the radius to 11 like that. And there you go. This is pretty much it. Now what I'm going to do is go over here into the animations and right click, and over here we have the enemy animations folder, and inside of the enemy animations folder we're going to have a separate folder for every single one of these enemies. So we're going to have ice zombie, then I'm going to duplicate it, and this one is going to be our imp, and duplicated masked orc, and duplicated swampy. There you go. So first things first, let's go with the iZombie. Over here, create a new Animator controller, and this one is going to be the iZombie controller, or simply call it iZombie, however you want to do that. And let's attach the controller over here. I'm also going to create the controllers for all of these. So next we're going to have the imp. Why is it, why? What just happened? Enemy animations. Okay, for whatever reason, I have deleted the imp folder. So imp, let's go inside one more time. I don't know what that was. Let me see over here what that area is. I will probably have to restart my Unity. I don't know. Anyways, let's go over here, Animator controller, imp controller, and attach it on the imp game object or enemy. And again, I know these things are tedious. They can be tedious. This one is the masked orc controller, but this is part of game development. So in any software development, basically any job that you do, there will be things that take time that are not as fun as some other parts of your job. That is totally normal. So over here, swampy controller, and that was some psychology, how can I say, psychology classes. Okay, you owe me $5 for that. Anyways, let's go here with the swampy, and for the animations we are going to right click and we are going to create the idle, and we are also going to create the walk animation. So idle and walk, there you go. Moving forward, we are also going to have the death animation for our swampy, but then we're going to reuse the death animation for all other enemies, because the death animation is essentially going to be the same. Now next, moving forward, this is our masked orc. So I'm going to go here in the masked orc and create the idle and create the walk. Now don't create the death animation for it, because we are going to reuse the one that we created for the swampy, as I already mentioned. So next over here we have the imp. Let's go back into the enemy animation. And here for the imp, this one is going to be the idle, and over here create a new clip. This one is going to be walk. Voila. And last but not least, we have the iZombie. So create his animation over here. Let's go over here and iZombie. Voila. Then we are going to have the idle, and over here again create, we are going to have the walk animation. So now what is going to happen? Let's go first with the swampy. So over here we have the animation. Let's go inside of the sprites and the enemies. This is the enemy death animation. I'm going to go here, set the filter mode to point and change the sprite mode to multiple and hit the apply button. And over here in the Sprite Editor, I'm going to slice all of this. So we are going to slice it like this, but essentially, no, we don't want to, we don't want it to be sliced like this. As you can see, some parts are not sliced and all of that parts, yada, yada, yada. So what I'm going to do is the following. I am going to take this one over here, and we are going to set the position X over here to 3, not 83, but 3, Y is going to be 0, and over here 23, 32 for the width and the height. And then we're going to do the same thing for all of these. So over here X is going to be 33, Y 0, width 23, 32. There you go. This one, and let me just see over here. Actually, I changed so this one, it goes at 3, and this one over here is at 33, 0, and then 23, 32. There you go. Why didn't it allow me to do it right away? This one is going to be 63, 0, 23, 32. Now moving forward for this one over here is going to be at 93, 0, 23, 32. Now we do need to delete some of these. So delete this one. I need to hold shift and press delete. So again, hold shift, press delete. Like that. We don't want any of these unnecessary slices. So for this one, it's going to be 123, 0, 23, 32. And last but not least, over here, we are going to have 152, 23, 2. And this is going to be our enemy death animation. Basically, I'm going to use this death animation for the player as well, and for the boss, and so on and so forth. So going over here, we have first our Swampy. Let's go here for the Swampy, and this is his idle animation, so simply drag it over here. Next, we have the walk, so select the run animation, and last but not least, we have the death. So let's go back over here, select all of these frames, and put them here into the death animation. That will be it. Next, we have the masked orc. For him, we only have the idle and all of those animations, so idle, put it over here. We have the run, basically we named it walk, put it over here, there you go. Next we have the imp. Now going back over here, what does imp mean? This is how the name of that file is, so I don't know what it means. Maybe it's something funny, so I want to laugh, please tell me. So let's go over here, imp, and last but not least we have the ice zombie. So let's go into the enemies and ice zombie and the idle animation for him. Drag and drop it, there you go, and the walk, run animation over here, and voila, there you go. Inside of our animator is where we are going to, have parameters for all of these animations and so on and so forth. That animation, by the way, is not going to loop. I'm also going to go over here in the parameters and create 2 parameters. One is going to be a Boolean parameter for the walk. So over here, I'm going to say walk, and another is going to be a trigger parameter for the death. So from any state, we are going to make a transition to the death animation, and that condition is going to be when death trigger is called. It doesn't have an exit time. It also doesn't have a transition duration. Now, what is any state? Any state basically means no matter which state we are in, be that idle, walk, or even if we have a gazillion other states, then we are going to transition. When we call the trigger, all of those other states are going to stop working, and then we are going to transition to the state that this, how can I say, transition is pointing to, which is the death animation. Over here, walk and idle and walk. There you go. So the condition is when walk is equal to true, you are going to go from idle to walk. Of course, no exit time, no transition duration. And over here, when the walk is false, then we are going to go from walk back to idle. No exit time, no transition duration. This is for the Swampy. Now over here we have the masked orc. Same thing, same process, except over here I'm going to right click and create a new state, which is going to be the death. There you go. And for the death over here, click on the list and find the death animation. So over here, here is the death animation. Again, create the Boolean for the walking and the death for the trigger. Now you can finish this up for the masked orc, imp, and ice zombie. Same process, exactly the same what we did here for the Swampy. So just finish it up so that you don't have to watch me make transitions. So over here, transition here, you get the point. The trigger or the condition is going to be here, the trigger, the death trigger, no exit time, no transition duration. As I said, the same exact process that we just did for the Swampy, repeat it for the masked orc, imp, and ice zombie. So just put here the conditions. So when walk is true, no exit time, and all of that stuff. Of course, for the ice zombie and for the imp, make sure that you add the new state and the death animation. And that would be pretty much it. When you finish, you are going to go here into the prefabs and folder and enemy prefabs, and over here you're going to drag and drop them one by one, just so that we create prefabs out of these and don't lose the progress if anything happens to them, and so on and so forth. If something was not clear when it comes to this video, make sure that you ask in the comment down below, and I will see you guys in the next video. How doodly-doodly-do, peoples! So now we are going to wrap up our game, and that will start over here in the sprites, and then level, and actually level parts, and door 2. So we need to go here and open this Sprite Editor because we need to slice these doors that we have over here. And when it comes to these doors, so I'm just going to go here and slice them up. So you know the drill, it can get a little bit tedious, but should I sync to? I am propelled to sync to. Let me just delete this from here. So come on, there you go. This is one of the door, and I'm going to call it door 1, like that. And moving forward for this one, so over here, there you go. This is going to be our door 2. So door 2, there you go. Let's do this over here. Come on. There's not that much work to do here, just, you know, slicing all of these door parts. So this one's going to be door. I'm just going to copy this, door 3. We have 2 more, so we are done. And over here, I think that in the future videos, I'm going to prepare things like this and just wait for you to do the same, or, well, not wait, but you will pause the video and do that. And then we can continue. Door 4, and last but not least, this is, we know when the door is open. So over here, and over here, and over here. Finally, we are done. So this is going to be our door 5. And I'm going to hit apply so that this change applies to this prefab. And I'm simply going to now take the door 1, and this goes over here, set it on the level and 3. So it can be on the 3 for the sorting layer. And this is, well, actually, am I going to set door 1? No, I'm going to set door 5. So when it's not opened, so let me just take here, door 5 is going to be the initial one. Where is the locked one? Here it is, door 4 is the locked one, so I need door 4. How did I name these? Let me just see here. This one's door 4, this one's door 5. So locked, okay. Basically it needs to be like this. This is going to be door 0. There you go. So the opened one is going to be door 0. That is the name of it. So I'm going to take this one and take the door 4. And now this is how we want it to be. Now, of course, you can just rescale it a little bit, you know, scale the door just a little bit like this so that it fills out the, you know, the emptiness over here, the gaps that we had in this wall. Of course, you can take your time to make this a little bit better, but you get the point. The point is not to make this the prettiest game ever. The point is to learn, but I'm just, you know, telling you what else to do. There you go. So for this door, I am also going to attach the animator. So there you go. We have the animator component, and we are also going to have a box collider. So box collider, and who is going to be a trigger. And for that box collider, we are going to resize him just a little bit so that when we reach the door over here, we will simply load the new level. Now going over here inside of the animations, let me just right click and create a new folder for the main menu, door animations, and inside create the controller. So I am going to go here, animator controller, door controller, and attach that door controller over here. We're going to have 2 animations. One is going to be idle, which is going to be an empty animation, so idle, and the other one is going to be open or something like that. So we're simply going to say open, and that would be pretty much it. And going over here inside of our component, I'm going to create a Boolean that I'm going to call open. And this is the name of that parameter. So we are going to go from idle to open when open is true. No exit time, no transition duration. And of course we are, let me just quickly go here inside of our animation to drag and drop the animations for the open. So sprites, level parts, and here is the door. So we're going to drop them like this. Okay, they need to go from here to here. I should have renamed them otherwise, but you get the point. So goes over here, door 4, then here we are going to have door 3, then door 2, lastly door 1, and door 0. Finally. So let me just test it out. Yes, there you go. Look at that. it looks pretty cool. And of course, I'm going to set the sample rate to here and set this open, maybe, I don't know, let's say 0.5 for the speed of the animation, and uncheck the loop time. We do not want it to loop. So we do not want it to loop. Now we do need a controller for this door. So when we pass somewhere around here, where the trigger is going to be, so I'm going to say here door controller, like that. And let me just see where he is. So he can be somewhere here. Set the Z position of him to 0. And the door controller is going to have a box collider, who is going to be a trigger. And I'm going to resize that box collider just a little bit. So something like this can do. Probably he will, stretch all this way so that we make sure wherever the player passes, he will unlock the door. Also, I'm going to attach an audio source, so audio source on him, and this audio source is not going to play on awake. And over here, we're going to say gate open. There you go. This is what we want. By the way, your assignment is to create the sound effects for every weapon for the player. So make sure that you create the sound effects, the shooting effects for every weapon, 2, 2, 2, 2, 2. You get the point. So that is your assignment. And yeah, it's nothing hard, but just for practice. So let's go over here inside of our scripts and main manuscripts. We are going to have a script that is called door controller. This is one script. Another script, we are going to have the door. So over here, we're going to have the door if Unity opens it, finally, or creates it, to be more precise. Attach the door script on the door and the door controller script on the door controller. So what's going to happen here inside of our door controller is that we are going to take all of this here. Let me just remove it quickly. So we are going to have a serialized field. This one is going to be the private animator. So it's Animator. This is going to be the door animator that is going to, open the door. A private audio source, which is going to be gate open sound, that we are going to get a reference in the wake function. So we are simply going to say gate open sound is equal to get component, audio source component, nothing hard at all. And simply over here in onTrigger enter 2D, we are going to test if the collision.compare tag, and we collide with the main menu character tag. So if we collide with the player, we are going to play the sound. So we're simply going to say play the sound, and we are going to call the door animator, and we're going to say set bool tag manager open animation parameter to true. This is everything what we need to do. It's nothing hard. It's nothing complicated. Just, playing the sound and opening the door. While here inside of the door itself, we are going to create a universal way to load any level. So we're going to say here private string level name, level that we are going to load. And over here inside of onTrigger enter, so not onTrigger enter 2D, if collision.compare tag with the tag manager character or main menu character, if we collide with the main menu character, we're simply going to say unity engine.scene management.load, or actually scene manager load scene, and we're going to pass the level name, which is a universal one over here because we can control it. We can, set any name that we want. These are basic things, and we did them numerous of times so far. So for the door controller, we need to drag the door over here, the door animator. And for the door over here, we need to set the level name to gameplay so that we load our gameplay, and just make sure that everything is here in the build. So actually level 1, you see, I would have made a mistake. So it's level 1, not gameplay. So level 1, I would have made a mistake. And that would be pretty much it. If I hit the play button right now, and if I click to play the game, now I'm able to select the character, so I can click here on the character. If I come close, pay attention, now we are going to hear the sound. And the door has opened, and now we can go over here in the level and play the game. Now maybe just maybe, we can set the opening of the door to 0.2 so that the door opens a little bit slower so that we can catch it and maybe see it. I don't know. Whatever. It's not important. Let's try it out. Yeah, there you go. You saw it. Maybe we can even set it to 0.1. But this is not, you know, essential for the game. Whatever, just, you know, a small detail. Anyways, this is it. This is wrapping up our game. Thank you for attending this course, or actually this section of this course, and going through all of this. It's been, you know, I think this is 10 hours or so, and it's a really cool game. A lot of things learned here, and yeah, that would be it. Make sure that you do all the assignments that I gave you, and I will see you guys in the next video.